before we actually get started, a question. Who here has their background set up? Like, who here has has followed like the instructions in the wiki and they have a virtual machine running for the demo? Oh, a few people. Congratulations, you all pass. The rest of you, how many of you have Mac that are M1s or 2? Okay, first of all, how dare you come to a Linux conference? But the second thing, so the setup will not work for you because VirtualBox has decided not to support M1s and M2. But for you, we have a solution which also can apply to everybody else. We have some Linode instances running. So I strongly recommend that you set up your background setup. It's pretty easy. You install 2 applications, you run it, you download an image, you're good to go. But if you don't want to go through that hassle and you want to make me spend money, but it's not that much money. Linode is a good sponsor. Not sponsor, but Linode. You can go to that URL or that QR code, and if we did this correctly, it will take you to this. Hopefully yours will not be in Spanish. So these are Linode instances. You pick one, put your name or Unix handle or signature or anything next to the one, and that's yours for the entire workshop. And use SSH like that. That's the password. Machines, I will kill it as soon as we finish the tutorial, so you cannot mine Bitcoin between now and the end of the conference. So I'm gonna come back to the mic in about like 4 to 5 minutes and ask the same question again, and if 80% of the hands are up, we go started. All right? The question was, can I put the URL up? And the follow-up question was, can I make it bigger? There you go. But again, please do the background. It's better for you.
If anyone needs help, you can raise your hand, and one of us will come over and attempt to help you.
Attempt being the keyword.
Yeah, no guarantees. for people who just arrived, we are doing setup right now, or you are doing setup. We're just watching you do setup. If you are able to, if you're running Linux or are able to use the Vagrant instructions to do the workshop locally, just go straight to the GitHub and go to the workshop README and follow those instructions. If you're on Mac, how dare you? Just scan the QR code and reserve one of the Linode instances so you can do the workshop remotely. And raise your hand if you need help, and we'll come over.
So, but before you raise your hand for help, who here has their setup ready by now? Either SSH into a host? Okay, perfect. We're going to give a few more minutes. And then if you don't have your setup, that's on you. Present the scope. Fedora 39. I've never, so this is a company provided laptop, right? So if but yours is unmanaged, right? Okay, cool. So yeah, this is managed. I got it like in Fedora 36, 35, and then I have been upgrading ever since. Yeah, I didn't. I've never been used to like installing this OS over itself. I'm always like theme itself. So it's very weird to figure out like the left of Well, I'm always afraid that nothing will work. Yes. Okay, so we are gonna get started. Okay, so welcome to this workshop. Do you want to introduce the workshop? Okay, so in case you didn't know, this is Systemd 101. This is not a rehash of the workshop that we did last year, even though a lot of it is similar. But we decided to split the workshop of last year and added more content, so we split it into two sections, Systemd Basics and Systemd Advanced, right? So today is Basics. Hopefully you will all be here tomorrow for Systemd Advanced. As traditional, there will be snacks in the middle of this workshop, so if you stay, you can get to eat some delicious food. Yeah, and those are the ground rules. My name is Alvaro. This is Anita. We both work at Meta, production engineer, software engineering manager. But this talk has nothing to do with Meta. There's nothing in it that I would say it's particular to Meta. And we did that like on purpose. So this is all information that you can take home and use it on your own machines. So before we get started, who here is kind of familiar with Systemd? Okay, that's great. Okay, cool. So this is probably there's gonna be some sections of Systemd that it's gonna be a surprise for some of you, but it's good to have like people who knows about it. Well, I guess if you're in a Linux conference, like everybody should kind of be familiar with it. I'm assuming that this part is not recorded, so who here it's leaning positive towards Systemd in their general sentiment? Okay, good. Who here is leaning negative towards Systemd in the general sentiment? Okay, perfect. And I assume that everybody is in the middle. The thing starts software, so it's good enough for me, right? Okay, cool. So let's get started. We're gonna start with a little bit of small slide. There's no need to need it, and there's no need to actually follow the slides. After the slide, we're gonna do the we're gonna start the workshop. Okay? Do you wanna start the slide?
Oh, gosh. What is a service manager? Well, I mean, Systemd is a service manager. Yes. Oh,
Whoa.
gosh. Boo.
Should we get We can do that. Let's.
Yeah, we'll call AV back later.
No,
But
we have
in the
our-
meantime, I will try to choose speaker.
The speaker seems to not be
stage
working.
right, not working.
Yeah. Okay.
So I'm just going to keep going. So you'll hear us say service manager a lot. Basically, we're just referring to something that manages your services, or in this case, just the processes on your host. It allows you to define some operations for your services and also provide some guarantees about lifecycle, in theory. In the good old days, we had these init scripts, and that was our idea of service manager. And then you end up with a bunch of shell scripts that look a bit like this. And you have to kind of define all of the verbiage for how you want your service to actually operate. And there's like a bunch of boilerplate that you copy and paste from your previous shell script, because who knows how that worked before. The problem with this is it's not really clear how you start and stop a method. It's not exactly the same between each script. So for example, in this Cassandra example, why are there like 2 start commands? I don't know.
Yeah. For instance, if you were to ask on the previous command, right, what is the user that start Cassandra, it would not be clear unless you're actually familiar with all of those commands, right? So you now not only have to be an expert on the application that you're deploying, you also have to be an expert on batch and how to set up your startup scripts.
And nope.
So the slides, no, and these are going to be very short. So, but after this, we're going to go to the GitHub, and there is a GitHub where we do the tutorial. Sorry, the question was, is there a website where we can follow the slides? Go ahead.
And maybe even more importantly, there was no way to figure out whether your service was actually running and get any kind of observability or logs out of it, at least not in a standardized way. So we kind of named those problems, but additionally, boot and shutdown was slow. Like I said, getting logs was not standardized, so debugging was kind of hard. And at the time, Upstart and systemd were emerging technologies. And in the end, systemd won. So that's what the majority of Linux distribution these days are now using to manage their services.
Yeah. So this is just dealing into the territory of the workshop, but the main difference between, and you're going to see it when we start, the main difference between systemd and initd is that in your batch script that you were doing, you tell the initd what to do and how to do it, while in systemd you tell just what to do. Systemd will figure out how to do it, what is the best way to represent the things that you want.
Apparently that's expected, because one feed goes here to Brew, the other feed goes out to the world. It's being recorded on the
Okay.
side. So today, that's what we have.
Okay.
In theory, it's possible, but I'm not going to touch that equipment.
Okay. Hi, cool. So now the workshop, if you want to follow along, is on this URL. I'm going to give you all a second to go into the URL, and then we'll get started.
Oh, yes, we can get the URL back up. So the way this workshop is written is that you can actually do most of this on your own time if you just, if you fall behind or you're not able to get your setup or anything. You can watch us do it, and then you can also take this workshop home and like do it and follow the instructions. If during the workshop you need help or you get stuck somewhere, just raise your hand. One of us who's not speaking might come over, if you have a question, though, just to distinguish between whether you need help or not, please raise 2 hands, just so we know to call on you and answer your question.
Okay, so if for all of you who are doing background, the way that you start this thing is you do background up, and this will pull the latest background that we have built, that I built yesterday. Hopefully you already did. Go ahead. The question was, can I zoom in more? And the answer is yes. Is that better? Perfect. Okay, cool. So there's 3. Okay, we still have some Linode instances available, and if they run out, we can just provision some on the fly. So feel free to use them. Okay, cool. So once you do background up, background SSH should take you inside the machine, and this is hello Bowie. This is a virtual machine running on your host. It's run Fedora 39, if I'm not mistaken. It has the latest and brightest of systemd, and has a lot of like code examples already made for you. So we start with the so what you do on GitHub, you navigate workshop, getting started, and then the README, and this is exactly what we went through. So we can get started with systemd. Okay. Okay, that sounds like I can maybe make this work. Okay, cool. So okay, so what we are gonna where we're gonna start is basically the most simple part of systemd, which is creating system units, right? So what I ask people to do in this one is that in your terminal, you can go to etc system, you can do ls. Let me actually, yeah. So you can do ls and then do a folder called etc systemd systems. And then you're gonna see that right there is a bunch of files that has extensions. Some of these extensions are target, some extensions are service, there's gonna be timers, and other things. Those are the ones that we're gonna go and check out between today and tomorrow. So the first things that we probably want to do is that we want to create a file that is called my first service. So you can use Vim if you're comfortable with it, and then just copy the content of this into the file. You can use Nano. I think we have Nano, maybe Emacs. So this should be the simplest service unit that you can create. It's still a little bit more complicated than the simplest, but it gives you like a good understanding of actually how you talk to systemd, right? So here you see you have a declarative document instead of having a shell script that define how to start your application or where to store your PID files and all the things. You have a declarative file that tells you the description. What is your file, right? What is the service that you're creating? It has an application that you use to run. Has a policy for how the service is gonna has a policy on how the service is gonna restart, and has an install section that we're gonna definitely look at it later. But it basically, if you remember the good old run levels, those are your installs. So If somebody want to install everything that has to do with users, all they need to do is start multi-user target, and this unit becomes part of that, right? So there's no longer the need to put this into a particular folder. You can just describe what you're doing. This, though, assume that there is a script here that is called service whoami.py, and it's executable, right? So let's see if this is true. And you can go just copy and paste it and execute it. And this very little clown script, like everything that I write, is just display a bunch of information about the running process, right? It has the infamous Python syntax warning. It shows you like who started the unit, the scope, whatever that means. Ask like what is the main PID, whatever that means, and then it just print a bunch of environmental variable that, as you can see, those are, as Unix always do, inherent from my environment, right? So if I type env, you see that those environmental variables seems pretty similar. By the way, if you are using background or daily node and then you're in a Tmax shell, which you probably should, if you press Ctrl K, you can clean your buffer. So it's a good thing to like have image cleans. Okay. Okay. So now we have the service. So we have tell systemd what it has to do, which is how to start the unit. Now we need to tell it to start it, right? So and the way that it works is that you use systemctl, you do start, and then you specify the name of the thing that you just created. My first service.service. And you started, and very anticlimactic, nothing really happens, just returns. So yeah, what happened? We can go and change this and ask for status. And I know that today we take this for granted, but the fact that we have so much information about how a service is running for free by just saying, this is the script that you use to, like, this is what I want to start, it is pretty amazing. So you get a bunch of information here. First of all, it tells you where the service is defined, very useful. It tells you what is the status, it's running, it started running 18 seconds ago. It tells you a main PID. Okay, so this is interesting. So now you have a unit, and there's something in that unit that is the root of that unit, that is the main PID. It tells you how many tasks it has. Task is basically how much forks are running. So when you start an application and then you want to like chill out to do something, you need to fork an exec. Each fork counts as a task. It tells you how much CPU is using for whatever that means. And it has this beautiful, beautiful thing over here that it tells you cgroup. So before we kind of dive into this, and we have a tutorial for cgroups here, how many people here are familiar with cgroups? Okay, nice. This is great because like people know systemd, but now they might not learn much, but now they are going to learn a lot about cgroups. So before we actually talk about what our cgroups are, just imagine that cgroup is a control group and it's a way for you to impose restrictions on a service. But systemd does something very interesting with cgroups. It is for each service that it starts, it put all of the things that are on the service on a cgroup per service, right? So this one has a cgroup that is called myfirstservice.service, right? So it basically, when you say I want to start my service, it creates a cgroup, and then everything that starts goes in there. So now systemd can keep track in a better way of what things started with the service, right? So in the good old days, when you start Apache, and you want to like stop Apache, what you do is that you kill the main PID, right? To figure out, because Apache would write like a PID file. But you never really knew what did Apache started, right? So like sometimes you chill out and then you double forks or you escape the parent. So there's no way of keeping track of that. And then you stop Apache, but then there's a bunch of loggers running around. With systemd, that doesn't happen because systemd can keep track of all the services because it keeps track of the cgroup. And when you say stop the unit, it will stop the cgroup. So yeah. So let's do that. I believe that's the things. That is, let's stop the service. Oh, by the way, sorry. And here in this You can also see there is a little bit of the output of the unit, which is also kind of useful. Sorry, and the unit just sleep infinity. I will probably show you what the unit does, but later. So, okay, bless you. We can stop the unit. So to stop the unit, we do something very simple. If you do start for start, you do stop for stop. That makes perfect sense. So now let's go back and do status. And now you see that it provides you all the information that you need, right? So it logs correctly that systemd was the one who stopped the unit, where the unit was, what is the status. So it gives you all this information that you may want to have from the unit. Now, if you want this to actually start the service when the system starts, you need to enable the unit. And if we go here and we do systemctl enable, you're going to see that systemd creates a symlink for the service units that you just wrote, and it put it there into a multi-user target. Not to spoil the future, but what is going to happen eventually when you start your machine, systemd will start the first target that start all the targets, and one of those targets is multi-user. And when systemd start multi-user, it will start all the units that were installed by multi-user. I will do that in parallel as much as it can, so it makes boot fast. So far, everybody who's following along is following along, or there's somebody who is behind it? Behind or following along? Perfect. Success. We did it. Okay, cool. So let's move on to modifying a unit, right? Again, this is systemd one-on-one, so we have to go through all the basics so we can do better. Okay, cool. So let's do something very interesting. We can take the unit that we just modified, that we just created over here. In case if you're typing along and you don't know how to do this, you can do Control-R to do reverse search, and then you find Vim, which was the command that I used. Press Enter, it takes you there. And then we're going to add here the user nobody. Right? So in Linux, there's basically only 2 users that are present in every single host. So the first one is root. The second one is nobody. That is kind of like the only one that systems tends to agree on, and then everything else can even have like different UIDs. Okay, so we are gonna start. So we're gonna modify this unit, add the user nobody, and now by looking at the unit, you can actually see what user it's gonna run the service. That's what we want to do, right? All right, cool. So let's start the unit, okay? Gonna take some time. I'm gonna start it, and then systemd did start the unit. Like if I do status, you're gonna see that it started the unit, but it actually complained about something, right? So it says like the unit file or drop-ins have changed on disk, but systemd will not pick up those changes unless you explicitly tell it to pick those changes, right? This is mostly because you care about atomic changes. Like sometimes you need to modify more than one unit at the same time. So if you modify one and those changes get picked up immediately, like catastrophic things can happen, right? So systemd allows you to like reload everything when you start. So the way that you tell systemd to reload stuff. Oh, first of all, let's stop. And now you do this little command over here. Systemctl daemon reload. You do that, and it holds. What basically that does, systemd will go and read every single unit, and now you can start, and then nobody's complaining. Now the beauty of this is that, remember this old status? For some reason, I thought the user would have been the status, but yeah, yeah. So, and it shows that the user that I was using is nobody. Okay. I'm gonna do. There you go. So let's take a look at this script. Service who am I? The best way you can do this is you just cut the script. It's very short, but also you can see it because it should be on your bin folder. Service who am I? Yes, sorry. Those are hands for questions. Okay. It's do everything at a change. It's atomic. Sorry. Oh, yes. Thank you very much. Yes. So the question was, does systemd, when you do daemon reload, does it reload everything? Or you can specify certain things? It does everything at the same time. That was my understanding about a year or a year and a half ago. I don't know if that has changed. But yeah, it's atomic. I used to remember that this is like an event loop, right? So like it actually has to like reload everything, so it has to stop. So this process tends to be very heavy. You don't want to do that like every single time. Cool. Any other questions that people may have right now? All right. Oh, this doesn't look good at all. Sorry. Does this one looks better? I think it does. Okay. So let's see a little bit about the script that we are running. We're gonna abuse Python a lot here. We do some coding in shell and in C to show you later, but in general, we try to do most of our stuff in Python. So the script is pretty simple. It basically just figured out stuff about the unit. Then it prints this beautiful ASCII art. It tells you what is the user. It tells you what PYD was running. It tells you something, what is the service. And then it prints all the environmental variables. If there is a no sleep environmental variable, sorry, as long as there's no sleep environmental variable, what it does, it goes and exec into sleep. So whatever, if you saw here into the terminal, when I did status, you see that the thing that is running there, it's sleep infinity and not and not the actual exec unit, right? So it keeps track exactly what it is. It kind of also tells you like the PYD. So, and question, because I didn't realize, do you guys see the, is, okay, perfect. That seems to be better. I don't know if it's the best, but it's the best I can do. I go. So, where were we? Oh yeah. Okay, cool. So, yeah. So we already went for what the script does. So let's do some journal CTL, and let's learn a new command, right? So you can paste that journal CTL command. And this is actually quite interesting, right? So journal CTL, it's one thing that comes out of the box with systemd. We have a full session on it. But for now, what it does is that everything that goes into std out or std air of your unit gets logs into the unit, right? So you get log for free. No need to start like skimming into var log, my service.log. Even though you can still do that. But the point is that systemd journald will log your things, right? So now you can actually see the entire output. Remember that status has a little output at the end? Now this is like the entire output. And you can see that it shows like the information that we were looking. Yeah, no need to know everything, but in general, this just tells you, show me the last 30 lines. No hostname tells me, don't show me the hostname because that's boring. And then .u tells you, show me the unit. If you were to remove, let's do this just because of fun. If you were doing journalctl.f as follow, as you do with tail, and don't put any unit in it, you are gonna see that it's basically just showing you everything that happened on the system, right? That's not part of this tutorial, but I thought it was a fun thing to know. Okay, cool. So, override units. Yeah, perfect. Okay, cool. So, let's do some override units. So there's a few ways in which you can edit a systemd unit. It's a text file, so you can just beam into it, and then great, you're good. But maybe you want to do something that is called an override. And the override is pretty useful, right? So imagine that you are a package maintainer, and then you are creating your service. And your service, like, I don't know, you decided you are Nginx, right? So when you install the Nginx RPM, it comes with a systemd unit, which is the thing that the vendor tells you or tells like how their system should start. You don't want to modify that unit, right? Because like if for instance, if you want to change the user, that system did start the service. And you don't want to modify that unit because if that's managed by an RPM, when you reinstall, either the RPM will decide not to upgrade that version, or worse, it will override it. RPM will not override it, but in general, like it will, like every package manager can do that. So the way the systemd solves this problem is by allowing you to have override configs. So these are configs that you put next to your configs that allows you to extend it. Or what is the opposite of extended? Reduce? I don't know. Like if you don't like if something start as a user and you don't like it and you want to remove that option, you can do it also with overrides. There you go. So let's do this. Okay, so the way that you would do this is that we're not going to do it like this, but if you definitely just want to do this by hand, you create. Remember, your unit was called myservice.service. So if you create a directory there called the name of your unit.t, and then add any conf inside of it, this is called an override unit, right? So and whatever you put there, system is going to load the unit and then load your conf, and whatever the conf does, it's going to win. But instead of doing that, we can actually do this thing that is called systemctl edit. Since systemd already knows where the files are and where it has to put the files, like, sure, it must be nice to help people out. So if you do systemctl edit, you get this beautiful thing, right? And it tells you, hey, I am doing exactly what you were planning to do by hand. I am editing etc systemd system my first service.service.t override.conf, right? And it kind of shows you the previous unit. So this is still exists. This is the other unit. Whatever you put here, it is what it is. Okay, cool. So what are we doing? Oh yes, we are adding an environmental variable. So we don't have to put everything again. We don't have to specify everything. We're just going to say for service, the environment add special m equals activated. I think we can just save it, and then it tells you successfully install. So, oh, sorry, there was a question, Anita. You probably know this answer better than me, and another one. When you do daemon reload, systemd reloads all the units, right? But can you reload just the unit that you modify?
No, if you just the contents itself, you can't do individual unit reloads.
Yeah, I did remember that. Yes. So yeah, cool. I didn't lie to you. That's good. Okay. So that's the one. Okay. So let's do. So we modify the unit. We added stuff. So let's restart the unit. Perfect. By the way, when we did systemctl edit, systemd also take care of the heavy lifting of not only finding where the unit is, writing the override, saving it. It also reload the daemon, so you don't need to do daemon reload if you do it this way. So I restarted, and then we're gonna do this journal CTL thing over here. So I know we're dumping a lot of syntax to you, and like we say, it's 15 lines, the unit, and we're doing G for grep. So we're grepping this content of this line, right? So if I do that, it kind of shows me that the unit that with that PYD has the special M activated, which is the thing that we added. So great, it works. Okay, so okay, cool. So let's modify the unit again. And now you can see that we have the previous unit. Let's add this memory max over here that is 10 megabytes, right? So we're just setting one of many systemd options to control how much memory the service can use. We save it. And then we can do the following. And this is why I wanted to do this. I remember now. Now you can see that there is an override, right? And then that the memory here is set directly to max, right? So I want to explain why do I think this example is useful. Remember that we changed the user. And we add an environmental variable, and we needed to restart the unit for that change to pick up, right? But now I changed another setting, which was the memory, and I didn't need to restart the unit for it to pick up. So anybody here can say, why do you think this happens, besides making life inconsistent? Yes, go ahead, anybody, just shout it. Oh yeah, but we also did this with an override file, right? So the thing is that it has to be something on the option. You wanted to say something. Okay, cool. Go ahead. Sorry, I didn't hear you.
Maybe if you see that a running process needs more memory, you can give it more memory without needing to restart it?
Yes, so it's that. I will repeat in case that didn't sound. She said that if the process needs more memory, you can just give it more memory. You don't need to restart it, and that is true, right? So like systemd will try to do its best not to restart service and not to need that. And in order to restrict memory, what you do is that you modify the C group, which is something that you can do live, right? While adding an environmental variable, you can only do it at the startup of the application, right? So those are kind of things, right? So in a way, this does abstract you a lot of trying to understand what's going on under the hood. But the point is that if you do it with edit, systemd will take care of doing most of the heavy lifting for you. Yeah. Okay, so that was it. And yeah, and this is, we hit, go ahead, 2 hands, go ahead. The question was, can I talk about some cases for the systemd overrides? So the one that I give about Nginx, it's kind of pretty common in terms of vendors, right? Nginx is kind of the default application that my brain goes, but in general, like if you're a vendor and you want to do applications, that's what you do. The other thing is that if you're a system administrator, one of the things that you tend to do, you also add certain overrides, so that every application that runs on your host like has a firewall, which is an option that you can add, right? Or you have or you run something before every unit start. There's an option that is called exec pre-start or pre-exec start, or something like that. That is something that starts before your application starts, right? So you can add something to log, I don't know, right? So those are the kind of things when you want to do modifications on the unit without actually touching the unit. Do you have another example of that, Anita? Isn't the one that comes home with Fedora? Yes. Okay, so Fedora comes with an override. What does that override does?
The one that changes the abort and timeout behavior on units. That's supposed to speed up startup. I mostly use overrides to override vendor shipped units. Like if they have something for SSHD desk service and I don't like a certain behavior, I would use an override for that. It just really allows you a way to further tweak what's already on the system.
Yeah. The Fedora one that you were saying, is that like the Fedora, like the Fedora pack? Sorry.
Fedora. Yeah, Fedora also ships overrides for their units as well, or like certain packages units.
Yes, okay, cool. So the rest of this part of the tutorial are us just going through a bunch of systemd commands. It should go pretty fast, and then we're gonna take our first break, because it's unfair to keep 3 people like locked up for 3 hours. And then you get to hear Anita instead of me, so that's a plus. Okay, cool, so this is quick and dirty walkthrough to some systemd commands. We already went to status, and then the unit name. You already saw that. What you didn't saw is that you can do status, and you don't need to put a unit name, right? So if you just do status, just like that, it shows you a kind of a list of the system from the point of view of systemd, right? So basically, you're asking for the status of PID1. So, sorry, not the status of PID1, that's not what it is, but it kind of gives you like, oh, so these are all the things that are running, all the processes, kind of like give you like a nice overview. Since it's a virtual machine, it has very little going on. So that's cool. Now, a lot of the time you do PS aux, and then you see all the processes. You don't know what's the PYD, like what's the service of a unit. Like if I do PS aux F, you're gonna see that list, and yeah, there's a sleepsfinity, but I have no idea what's the unit that is. So I cannot ask for the status of that unit. But what I can do, that I can ask status for 5423, which is a magic number. No, I'm lying. It's the PYD of the unit, right? So if you just know, sorry, of the process. If you just know the PYD, systemd will, since it's keeping track of everything that is under the hood, you can use systemd status by the PYD, and that's all good. If you do systemctl without the status, you get a horrible view, but it does tells you like all the units that were executed in the service, sorry, in the machine. So it has a lot of information, and if one of those is red, it means that it failed. Nothing failed here. Okay, so that's status. Very nice, very useful. Now, assuming now that you do know your service, like this one, and you want to actually see the content of your service, you can do systemctl cat and the name of the service. Again, since systemd knows exactly where everything is, it can nicely assemble the list of files for you and display it. Very useful. And it displays exactly what we say it should display. Now, if you don't want it to cut, if you want it to show, whatever that means, we know what it means. There, it will kind of tells you all the all the properties that has that the unit has set. Right. So these are all the options. Go ahead. Yes, 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 yes. So yeah, you definitely can do. So the thing is, systemd keeps the status of the entire. So the question was if we can use this to pick what you can put in override, and the answer is yes. Systemd keep a list of all the things that are running. And for each service, it has a full list of properties. So if you set ones, the other ones are the default value, right? So now this will show you everything, so you can override whatever you want. With that said, if I'm not mistaken, this one is using the Divas interface. So we're going to go that. So this doesn't really map one-to-one to the actual setting. Like for instance, here it says restart you. I'm showing. Yeah, so it says restart U seconds. Oh, let me go to the terminal. Restart max U second. That's microseconds, I believe. Yes, it's microseconds. The unit, the settings is restart max seconds, right? So you don't use the U seconds there, or runtime max or time or something like that. You can check the docs, but that's nanoseconds. Nano. Okay, sure. Okay. Math is hard. Okay. Oh yes, no. Okay, perfect. But yeah, that you can do. You can also inspect just a few settings there. So you don't need to watch everything. You can just specify that P, and it will tell you what it is. And here's what I was telling you, right? So you have exec start, and it kind of shows you the way that systemd sees this option, right? Like with all the different properties. But it's kind of like if you want to know the main PID, you can do this main PID. But do specify the unit. And this is very useful also for shell script. So if you specify like that's P main PID, it will tell you main PID equals and the PID. You can also add this option over here that is called value. And then it will just give you the value. So you just shove that into an environmental variable, and you're good to go. Yeah. Any question, comments so far? Yes, you can. Please interrupt me.
So the thing with systemctl show is that it only has what systemd is stored in memory at this moment, and that's not necessarily the same as what's systemd is already running. So certain properties, once the unit is running already, that's it. But you can reload and change the unit, and systemctl show will show what systemd has in memory, and it's not exactly the same. So just keep that in mind when you're looking at show and you're confused. Like this says this one setting, but when I'm actually running the service, it says something else. That's why. Yes, question.
Yeah, so the question here is I'm going to paraphrase, you pick at the word watchdog and ask if you can set the watchdog per service, and the answer is yes, you can. And we actually have a tutorial for that, which comes tomorrow. Yeah, so many things you can do. Go ahead. The question was when you use systemd kill is when the service doesn't respond. So no. So if you do systemctl stop, if your service is unresponsive, you can still use systemctl stop. It will send a sick term to the service. By default, you can change all of this, but it will send a sick term, and after like a minute, if the unit didn't die, it will send a sick kill. So the stop is supposed to kill the process at the end of the thing. Very rarely fails. Systemd kill is when you want to send signal to the process, right? So the same way that when you use the kill command, you say like kill and then you send like a sig hap, right? Systemctl kill, you can do that, but you don't need to know the PYD, you just need to know the service name. So you can say kill, for instance, chub to nginx, and then systemd will figure it out what's the right way to do this. So with that, we're going to do systemctl kill. And yeah, it is exactly that, right? So you send the signal. Yeah, but this is actually quite interesting. So I'm going to send the signal kill 9, like touch 9, like SCaLE. Like there's no coming back from that. And then I'm going to do status. That's not the status that I want, that's the status. Wait. Did I send the signal? Oh, great. Sorry. Yeah. So you can see like the unit's still running, but the startup time is 7 seconds ago, right? So what happened there is that I sent the SCaLE, like systemd send the SCaLE to the proper main PID. That thing's died, but the systemd has this setting that you remember that it says like restart always that we put it. So the unit restarted, right? So that's kind of like intended. If I were to do stop, and then do status, you see that the unit is stop. Is it stop? Yes, it's stop. Right there it says, right? So the difference was that systemctl kill. After that, the output is not that the unit has to remain stop. While you do systemctl stop, systemd will kill the unit, and then after that, it will ignore the always restart because you were explicit. I actually wanted to stop. Otherwise, you will never be able to stop your unit. But it's very useful. I would think like kill is such a bad name for this. Yes, it's the Unix kill, but also the Unix kill has a very bad name. So there is a systemctl list unit, which is the same one that we already. So when you call systemctl with no parameters, it's exactly the same as calling it with no units. Sorry, with list units. So this one, it's exactly the same as this one. And that again shows you like a nice view of everything that has run on the service. While systemctl status shows you everything that is running on the service, right? While the other ones shows you like things like these weird devices that are for mounting your TTYs that will not appear otherwise. Did you add this or did I add this? I didn't remember this. Did we add this? Did you add this? Okay, cool. Good pass, Alvaro. Okay, you have list units. So yeah, no, yes, this is an awesome me. So thanks, Anita. You can use wildcards for searching. You're basically saying like, give me all the service. You can do that. It's also very useful. Yeah, it also works with systemctl status. Like it's the wildcard, right? So it kind of shows you like everything that has a service. You can be more specific than just service, but that's it. And I think there's other things that are cool. It's called list pass, list socket, list timers that do all those things. And it's 11:04. I think it's a good time for us to take at least 10 minutes, bathroom break, coffee break. Thank you very much. If somebody have questions? Oh yeah. So is it time for Portos? Yeah, and your prize for being, your reward for being here and learning about systemd is that we have some Portos pastries here. It's time? Okay, perfect. Niche approved. So yeah, so you can come and grab some Portos pastries. They're free. You don't have to pay. You just have to eat them. Thank you, by the way. Okay, 4 minutes, and we'll get back to these fun times. What a great town Venice is. Yeah, I was scammed out of coffee. There's no coffee.
Check, 1, 2, check. Okay, we are ready to get started. So if people can take your seats. Escape. If you like piña colada. Okay, so for the last part of Systemd 101, we're going to talk about ephemeral services. So Systemd provides a way for you to just kind of generate units on the fly, like you don't even have to write a unit file. The only downside with this is that it doesn't preserve the unit between like restarts and things like that. It's just stored in memory. So we can give that a try by running this command here, systemd run service whoamipi. It's the same one we've been using before. So now you see that systemd created a unit file and it's starting to run it. We can take a look at the contents of this unit by copying the unit name. And doing systemctl cat. And you can see that systemd stores the unit file in /run, which is in memory, and it has the contents of what it generated here. So it should look very familiar to you already since you created a basic unit at first. The other thing you can do with systemd run is create an interactive shell. So if you do systemd run -- shell, this will kind of drop you into the shell inside of the systemd unit. So you can do systemctl status to get what the PID of this unit is. And you'll see that from within the shell in the systemd run unit, it looks kind of like this. You can go ahead and play around with this for a bit, but it's basically just another bash shell within a bash shell. And then when you're done, just go ahead and exit, and you'll be back on the host or the virtual machine, wherever you are. Any questions about that? Oh, a question. The question was, why might you want to do that? Do you mean systemd run or systemd run shell? Shell. Okay, so one of the useful things about systemd run shell is that if you're debugging some kind of complex behavior with your unit, you can use it to kind of drop into what the state of systemd is like. For example, You got an example, Alvaro?
Yes.
Yeah.
So, well, you can use this for tutorials and show how things work. But in general, it's kind of like looking at the world from the point of view of the unit, right? So, see, later we're going to see that systemd can do things with your file system. So the unit may think that root is read-only, right? So you may not really know that that becomes a problem, so you can start a shell with root as read-only, and then do the commands that your application would do, and that gives you like a nice feeling of how the unit works. That is kind of very useful. But we use it extensively in this tutorial, because like we ask you, like, modify this. Now go into a shell and run a few commands and see what the effect that has in the world.
I'd say like just systemd run shell by itself may not be super special. But once you start getting into like the sandboxing properties, and you run like another process along with the shell or something, you'll be like, hey, why isn't this running properly compared to outside of the host? And it's because of how the systemd property is behaving. So it kind of allows you to test some of those in more detail as well. Any other questions? So the question was, how does systemd know to drop into that particular shell? I mean, it's creating the unit at the same time as it's dropping you into the shell, or like it creates it, runs execs, and then you're like in the shell there. It connects the pseudo terminal there. Does that make sense?
So you have two shells. Two shells.
Yeah.
Two shells.
Yes.
This becomes more clear maybe in the second example. So we're going to start using systemd run shell more extensively to run an interactive process. So So systemd run shell is pretty much the same as adding this --pty argument. So you can do more fancy things, like I was saying, by copying this command. And we add dynamic user true, which is one of the properties that allows you to run the process as a random user. So let's go ahead and do that now.
Sorry.
So we do that. You'll see now that the service whoami Python script that we ran before is now running as a kind of random user that systemd has generated. Later in the workshop, we'll talk more about how dynamic user works, but just know that it's one of the ways you can use it to run your process as an arbitrary user. And that's it for the very first basics of systemd. Are there any questions about this part before we move to the next part of the workshop? All right. Back to the table of contents. All right. You want me to do this one? So now we're going to start talking about other systemd unit types. So far, we've pretty much only talked about service units because those are the ones that allow you to actually run commands and execute processes. The systemd has a whole suite of other unit types that allow you to do other things. So for example, timers. If you are familiar with the cron tab, it allows you to kind of periodically run an executable or something on a schedule. And so if you recall the cron format, if you run something every 10th minute, you can do it like this, and then you add the script or whatever at the end of the line. To do that with systemd, you use a timer unit. So we can go ahead and create a timer unit with these contents. We're going to use systemctl edit so that we don't have to worry about reloading the unit later. I'm going to copy the contents. So the difference between a service is this timer section here. And the property, one of the properties under timers is on calendar, and that allows you to kind of insert a cron style format and allow you to run the timer. And if we want this to run at, or like start the timer at boot, we also added this install section, and it's wanted by timers.target. So let's go ahead and exit. Because we use systemctl edit, it already reloaded for us. So that set up the timer section. How do we actually include the script that it's supposed to run? We do that with by creating a service unit of the same name. And we can copy these contents here. And this is just a generic service unit like what we saw before in the previous tutorial. What this is going to do is run service whoami, a Python script you're already familiar with, and set the environment variable to no sleep equals no. Let's go ahead and save this as well. And now we can actually go ahead and start the timer and watch when it fires. So I'm going to go ahead and copy this, start the timer, and we use watch here to see when the status changes on either the timer or the service unit. saw that the timer executed, and the service status now spits out the usual logs that you're familiar with. See. I guess the other thing worth noting about the timer is the, I guess, let's dig into the status of the timer unit a bit more. So let's delete this watch command. So if you're already familiar with systemctl status, on timers we also get this trigger and triggers behavior. So what that does is it will tell you when the timer will next run and trigger this service. There is a property where you can actually change the service that the timer triggers. You can kind of look that up in the man page, but by default, if the service has the same name as the timer, it will trigger that service. What else is interesting here? We already know about loaded. It's when systemd had loaded this unit into memory. Yes, question?
What is the advantage of using systemd timers versus the old say cron jobs?
So the question is, what's the advantage of using systemd timers over the previous cron jobs? So using on calendar, we don't get to see a lot of like the special sauce with timers. We're going to go into some more properties later. But I think the primary advantage is that we can actually trigger like a whole service file. And with that, you can define, you can fine-tune the behavior of how the command should run in relation to the timer. Whereas with cron tab, it just kind of runs the script and then it exits.
So yeah, so that's one. There's other two things that I think are kind of like mainly superior to cron, but first, let's say like cron, it is very simple and it is very familiar. So like you can use that one if you like, right? But yeah, so the first one is the use of time. Systemd has monotonic, so you can say trigger this 5 seconds after the previous execution, or you can do since boot, do this half an hour after boot, like those kind of things. Like it doesn't have to be tied to a particular time of day. There's also flexibility in giving you like splice. I don't know if that's the right word, but it is like start this at 1 plus minus 5 seconds, right? So you can distribute a whole set of things in time, right? So that's the first one that I would say it's pretty useful. And the other one, it is where the strong suit of systemd is that you actually get status and logs and like in cron, it's really hard to see if your thing ran and what was the status of that run. You need to inspect logs. In systemd, you just say like status of my timer, and it will tell you, yes, I was here, I did what I was supposed to do, and it exited successfully or failure, right? So it kind of gives you that.
Well, now we're going to see all the things that Alvaro just described. So starting with the monotonic timers, let's just go ahead and edit our first timer and change on calendar to instead use on active 30 seconds. On active sec equals seconds. So what on active second does is it basically says, let's just run this or execute this timer 30 seconds after we activate the unit, and basically it will never run again. So you can also combine this behavior with, that by itself is probably not super interesting, but you can also combine it with like on calendar, on active seconds, on boot, and things like that to further change how you want to start the unit behavior. Should I run it?
Yeah.
All right.
Start and then go into your have a status.
So let's start the on active 30.
You can go into the watch.
Yeah.
Will trigger 13:11.
So if you're looking at this watch, you see that there is a countdown till the unit's gonna trigger. Oh my god. Ugh. Okay. Great, it triggered. And in theory, if we if we look at it again, it will not show like a next trigger time. So, yeah, it elapsed, and that was pretty much it. Their system has a bunch of different properties like that. In the next example, we have on active seconds, on boot seconds, and there's probably a few more that I'm forgetting, but you can always look in the man page for the rest. Okay. Okay, so similar to ephemeral service units, you can also create ephemeral timers if you just kind of want to run something on the fly. So if you do systemd run on active 30 seconds and just echo this, echo hello from the past, it will automatically create a timer and the corresponding service unit for you. As seen here, you see that it's now running this timer unit, and it also runs, will run this service unit when it fires. And similar to before, you can do Control-Shift. And you'll see that the timer is already active, and it's just waiting to, well, it probably already ran because I didn't do the watch. It already created the service and the timer, and it was going to fire it after the 30 seconds.
Yeah, and it tells you that it expired 15 minutes ago?
Yes, and thanks to Alvaro, we can see that, well, it was active 39 seconds ago, and it already fired down here. Hello from the past.
Yeah.
So the other thing Alvaro was talking about was SCaLE. So if you're managing like a fleet of hosts, and you don't want every single timer to kind of start at the same time because that would overload whatever service you're trying to make them call or something like that, systemd provides a way to automatically randomize the when the timer execution actually fires. So to do that, you can use a randomized delay seconds. I also like to combine this with fixed random delay, because if you have fixed random delay equals no, every time you actually reload the unit, systemd will change the amount of randomization that goes into when the timer executes. Yeah, it'll make it random every time. So it's not going to have like a consistent random delay. So let's look at this unit as an example and its contents. Can someone tell me what it does?
Brave soul? Any brave souls?
Sir over here with 2 hands.
I'm going to guess and say that it will run every 30 seconds, but with a random give or take of 10 seconds, but probably the same random give or take of 10 seconds every time.
Yeah, that sounds good enough to me. Yeah.
Congratulations, you win Portos.
You also, I actually don't know. I'm actually bad at reading cron tab. I believe this is 30 minutes, right?
Yes, it is.
Yeah.
Yes.
So this will run the timer every 30 minutes. Sorry, not totally correct. You didn't say you
No,
said
this
seconds.
is seconds,
Oh,
right?
it is?
It's seconds.
Okay, never mind. I'm wrong.
Yeah,
Yes, they'll
it's-
run the timer every 30 seconds, adding up to 10 seconds of random delay.
Yeah.
Okay, so extra stuff we won't cover. Like I said, there are a bunch of other properties you can use to set your timer behavior, such as when the clock changes, when the time zone changes, or when the system wakes up. Ooh, actually, one thing about time zones. This is a big gotcha. When you use on calendar, it uses your local time zone. I know, it's crazy, right? So like when daylight saving comes around and your timer doesn't fire for like the next hour, that's probably why.
So on calendar uses the calendar.
Yes, yes, I mean, it sounds obvious like on calendar, but that's a huge difference from the cron tab behavior. So you can actually stick a time zone on the on calendar if you like really don't want to, or you can use the monatomic timers, which are based on your system.
Or write things in UTC. UTC 0.
Oh gosh. Okay, so yes, monotonic timer.
Time is an illusion. It doesn't matter. Yeah.
All right. So we're not going to go over every single unit, but the other interesting one you'll probably want to know about are path units. So what path units allow you to do is kind of watch a file or a certain path and then run like a service or something when that file changes or it's modified or it's created. So let's go ahead and create this shconfig watcher path. And I'm going to copy the contents from our GitHub by clicking the button. Oh, okay. So let's look at what we have here on this path unit. Similar to service and timer, it has kind of a path type or header, I don't know what you call this. It has a path change property. So what we're going to do is watch when etc shd config, the contents are changed and saved to disk. And of course, we need the corresponding service unit along with it. So we're going to go ahead and do that. So just copy it from GitHub. So what the service is going to do is when the path unit fires, we are going to systemctl reload shd.service. I got a good question during the break about systemctl reload. So certain service units define a reload behavior. SHD is one of them. You might want to do this if instead of restarting your whole service to pick up changes, you just want to run reload and in your code itself, you do something to, reload the config or whatever. So let's go ahead and save that. And now we can actually, we'll go ahead and enable the path unit and then start it. And start. Let's see. Now we can check the status of SHD just to see where we're at. And you can see right now that SHD is just running normally, but if we, let's say we just modify the etc shd config. This is the file that we're watching on the path. Let's say that we uncomment these lines here to change the log level and then save it. If we look at the status of SHD again, you'll see that the process actually changed to executing its reload behavior, which is what we actually defined in the steps above to create the path unit and the service unit. And also the other interesting thing is that systemd tells you when it reloads, so you can see down here that systemd had reloaded SHD. Okay. Any questions about this? And then, of course, you can use systemd run to also create an ephemeral path unit like you did with timers and services. So let's just go ahead and copy this one. Instead of path changed, we're using path exists here. What we're going to do is when we create /temp/ping, we will touch /temp/pong. Let's go ahead and run this. And we can check that both ping and pong do not exist right now. So if we go ahead and touch ping, we will see that the unit ran and it created pong. Okay, so I have something like insane with the path exists behavior. So you would think that when you use path exists, it only runs the service once, like once it creates the file. But if you read the documentation for path exists really closely, what it does is while the file exists, systemd will keep trying to activate the unit. So if we look at the service here, the service that it created as part of the run, we can see that it actually hit the start limit because while that file was existing, systemd kept trying to start the unit. At some point, it hits the start timeout limit, and then it dies. It stops trying. So yeah, that's something you should notice, I guess.
Yeah.
Yeah.
Sorry, it's very useful. You have that gotcha. The other one is that this is using the, what's the name of the thing where it's iNotify? Yes. So as you know, iNotify, it's a best case effort. So you may lose some events of it. So like I would not extremely rely on it, but it is very useful for things like let your users add a file into the directory, and then you can grab that file and then shove it into another configuration or something like that. We did this for SSH once in the company, where Chef would write things into the directory, and this will basically create an SSH config and reload SSH when it starts. You can see that that is very dangerous and clowny, so don't do it, but yeah, that's what we did.
Right, so that's the end of the other unit types that we're going to go over today. Are there any questions about that? Nope. All right. Do we need a break or should we keep going?
I think we could start with time, 47, at least for 10 more minutes.
Okay. All right, so the next module we're going to go over is dependencies. And for some reason, Alvaro's really excited about this. So dependencies are, I mean, conceptually they seem kind of like easy to understand, but in practice they can get pretty complicated. So the, if you remember sysvinit scripts, you run the scripts sequentially based on how you number them, and there's not really a way to say that, hey, this script depends on this other script, except to order them in a certain way based on the file name. With this systemd aims to solve that by creating a way to define your dependencies, and when systemd will try to graph all the dependencies together, it tries to parallelize the execution based on how the dependencies are kind of linked together. And that's how you can speed up startup and shutdown. So instead of running everything sequentially, it aims to parallelize as much as possible. So what does this look like in practice? So let's start with ordering. Systemd provides two ways for you to order your units, with before and after. So for example, we're going to be talking about the dinosaur and human service. In the dinosaur service, we are actually going to write before human.service. so that when these two units run together, we actually have dinosaur.service running before human.service. So we actually provided these units for you already, so I don't have to struggle to copy and paste the contents into the terminal anymore. So we'll be able to just run this and see what happens. The other notable thing here is that on both of these units, we use remain after exit. I don't think we talked about that yet. What this does is it keeps the state around after the service finishes running so that you can examine it once systemd has in memory. This is pretty useful if the service successfully exits and you want to see what happened. So let's go ahead and copy the start commands. And to show that dinosaur ran before human, we're going to check the timestamps for both of these units. So we can do systemctl show -p. We use the active enter timestamp monotonic property, and we will first look at the dinosaur.service timestamp. And then we will look at the one for human service. And you will see, if you look really closely at the numbers, that the dinosaur service had activated before the human service. So yeah, super simple so far, right? Before and after. Okay, now we get into kind of the bread and butter of like the actual dependencies. So 90% of the time, I'd say, most people will only want to use requires and wants on their units. Systemd actually provides many more ways to define dependencies, but those really get into like the nitty-gritty of how you want to start, stop, and reload certain units. But most of the time, you just want to say this unit wants this other unit to start, or this unit requires this unit to start. So we're going to test this out with two services, life.service and water.service. On life.service, I write that it requires water.service, and we also want it to start after water.service. And water.service, we're going to run bin false. So what this does is it causes water.service to fail when it runs. And you'll see why I do this once I start life.service. Okay. So because I used requires, we would kind of expect that life.service will fail because water.service is going to fail, right? So let's start. This is another gotcha here because when you check the status of life.service and also the status of water.service, you'll see that life.service actually ran successfully, but water.service failed like I said it would. Why is that? Well, it's because requires only refers to the act of starting the unit. The default type for every service unit is simple, which means that as soon as systemd forks, the unit is considered started, which I think can be confusing because people have very specific ideas about when their process is actually started, right? You would think that when we exec and we reach the certain point in our process, this is when we want to start. So to do that, we can actually use type equals notify. So if we systemctl edit, water.service, and we change it to type equals notify, because in our command we don't tell systemd sorry, taking a step back. What type equals notify does is it expects your service somewhere in your code to tell systemd when the unit is started and ready to take, actually active. You do that by sending a command, sending a dbus message ready equals 1 to systemd. But because we're not doing that here, we will actually fail to start the unit.
We have a tutorial on that tomorrow. Shameless plug.
Okay. So now if we actually try to start life.service, it fails because the water service failed and it had a requires dependency. And you can see that systemd helpfully tells you that dependency failed for life.service.
So in the real world, this is useful, like when you want to start your web server after you start your databases. Like this is how you can do that. In general, this is how systemd start in general. Systemd says like start everything on the service that it's designed to start, and then it uses dependencies to map things out.
Okay, now we have a quick exercise for you to do. So keeping type equals notify on water.service, I want you to modify water.service to send a ready equals 1 message. And I give you a hint here. You can try using systemd notify to do that. Just take like 2 minutes to do that, and let me know what you come up with.
Tab competition on the unit, so you don't need to type the unit, you can just pick up. Remember we did
What do you mean?
sorry?
Okay, so who has managed to send the ready message and like gotten the dependencies all fixed up? Does anyone want more time to try and do that, or do you want me to do it? All right, ambivalence. I will go ahead and show you how I would do it. So I'm going to override the previous exec start by by adding a blank exec start here. And then I will use systemd notify. If you looked at the man page, you'll see that you can send a -- ready. And that's all you really need to do. So if we start life.service again, you'll see that it started successfully, even with the type equals notify and also water. If you look down, we deactivated successfully. And to do that in your code, you would use like the SD notify API and things. Oh, there's a question. Yes.
The question was, can you show the solution? And the answer was yes.
Yeah, here's the solution once again.
And again, we have a whole section of notify in general. There's a lot of cool things you can do with it, so stick around for tomorrow.
Okay. So we talked about requires. Now we're going to talk about wants. So wants is basically the weaker version of requires, because what wants says is that we'll make a best effort attempt to start the service, but if we don't do it, like no big deal, we'll just keep moving along with the original service. So we provided 2 service units here for you, dog.service and bone.service. Let's see. Bone.service has the same thing we had in the previous section where we use type equals notify, and we run bin false so that it purposely fails to start the unit. And in this case, when we actually start dog.service, it will run successfully because we don't have a hard requirement on bone.service. So let's just go ahead and do that. And if you check the status of dog.service, you'll see that it ran successfully and bone.service had actually failed. So yeah, any questions about the ordering and basic dependencies? Yes, question?
And you generate conflicts, like figures of each of 2 commands run before the other one, so that either will ever be able to run and the other one hasn't. Is there some, can you get them into a deadlock somehow? Is there something in system that knows how to handle something like that?
Oh, I guess the question was if you define the unit such that you create like a cycle or a deadlock, is there a way to detect that with systemd?
I'm not going to do something until you're not going to do it until I do.
Yeah. So like 2 units like depend on each other, and if one like yeah. Yes, yeah. I mean, you can create cycles on purpose, and systemd is able to detect and warn you about it. I don't know if we'll get to the verify section of the workshop today, but you can use systemd analyze verify to detect cycles in your units. And you'll see that the crazy thing is when systemd detects cycles on boot or like at a target, it'll actually delete the start of certain units in order to get past the cycle. Yep. Any other questions? Yes?
Does it know whether it was started by wants or requires afterwards?
Oh, does the unit know if it was started by a wants or requires?
The answer is yes. There's a lot of conditions in which you can basically say because like one of the things is that you can start a unit just because it's started by requires or wanted, but if you stop the main unit, you will not stop the previous one, right? So, but you can also set systemd to say like, if a user doesn't start this, like stop it when you don't need it. You can also say no one can start this unit except another unit by wants or require. So you can also like further. So the answer to the question is yes, and you can take advantage of the situation.
Okay. Now I'm going to talk about the install section of the unit. So you saw in the previous examples that we added install so that we can actually enable a unit, and most of the time we do that because we want a unit to start at boot. So typically we add this statement here, install wanted by multi-user.target. For most systems, multi-user.target is the default target that kind of signifies like the end of the user space. Like we booted into the system and this is it. There are actually multiple other targets you can do, but let's start by modifying, let's see, yeah, there are actually multiple other stages of targets that you can do, and let's actually do a quick experiment here where we add the multi-user.target to the dinosaur and human services that we did before. We're going to go ahead and copy dinosaur service into /etc systemd system and name it a.service instead. And then for human service, we're going to call it B service. And
Okay, so here's the disclaimer. This is the part that we haven't tried with Linode. So if you're using Linode and now you're going to reboot your service, your machine, let's hope it works and we don't end this tutorial earlier.
all right, everyone, you'll see that I didn't actually modify and add the install at this point. And the point of rebooting here is that we're going to show that both of those units did not start at boot. And while that is fast in my Vagrant machine, I don't know how long it'll take your Linode machine to come back up.
I did try a restart and it takes like a minute or two, so.
Yeah. I think we'll probably just skip straight to this, and we might skip this part.
Sure.
Just skip to the end of this.
Let's try to, if you can hold 10 minutes so we can give 5 minutes for break and then we can.
Yep. Did anyone do a reboot on their Linode instance and come back successfully? Yeah? Okay. All right. So if we do systemctl on A and BDAS service, you'll see that they did not start as expected because there's no install on those statements. So we can go ahead and add the install now by copying. Saving, and we also do the same for A. So what I did just now is add the install wanted by multi-user target part that I had above in the GitHub to both of those units. And don't forget to systemctl enable, which creates the symlinks on multi-user.target, because if you don't do that, it is not going to start at boot. And if we actually reboot this time, you will see that both of these services are going to start at boot. Any questions about that, or anyone need help?
What's that constraint setting the install as multi-user versus calling like enable?
The question was, what are the constraints between? What are the differences between adding the install statement and running systemctl enable? So you can only enable units that have the install section. You'll see that if you try to enable a unit that doesn't, it'll like give you kind of a long log line or warning about it. Basically what the enable does is set up the symlinks so that when systemd runs the target, it knows that these are all the different dependencies or services and stuff that it has to run. Okay. All right. So getting to the next part of this, we're going to start talking about synchronization. So I mentioned target units a few times, and you might be wondering, like, what the heck are targets? So targets is another unit type that doesn't allow you to specify anything about it except for like the default unit properties. And they exist to synchronize all the different services and stuff at different stages of boot. You can think about them as like the sysv init run levels. If you actually look at the man page for boot up, so just go to like man boot up and scroll down a bit, you'll see that there's a really interesting chart about how all the different targets get executed as part of a host startup or run. And you'll see that at the very end of it, the user space boot targets can be either one of rescue target, multi-user target, graphical target or emergency target. Graphical is like when you have GNOME, KDE, or some kind of graphical desktop environment. If you're on a server, you don't really have that, so multi-user target is where you end up. And you can actually add your own target if you want. So to see what the default target is, you just go run systemctl get defaults. And you'll see that the default target is multi-user target. The way the default target is defined is with symlinks, as with a lot of the other kind of dependency things. So if you look at the symlink for default.target, you'll see that it points to the multi-user target unit file. So the next part of the workshop, I just show how we're going to create a custom boot target. But in the interest of time, I'm going to skip that part now and just move directly into the showing you some examples of like how you can analyze boot with system analyze critical chain and things like that. So if you run system analyze critical chain, what it does is gives you kind of a rough, very rough timestamp of when each target ran when you booted your host, and the order that they actually ran. So in this case, we still had multi-user target, and these were all the things that had run before it, along with the timestamp. And if you like pictures and pretty things, you can actually use systemanalyze dot, pass it a unit name, and it'll generate this crazy graph of all the dependencies on your unit. And I'm going to try that now. Let's create a new terminal on the host. And let's, too big. All right, systemanalyze dot, I don't know, what's our favorite service? Yeah. So you'll see that this spits out the dot format for the dependencies of systemd. But this is not really useful by itself. We are visual creatures, so they say that we can actually use this to turn it into an SVG. It's going to run that again.
I don't know what.
Oh, sorry. I forgot to pass the... Yeah. And if we have an image viewer, we can actually look at this crazy graph. Year of the Linux desktop, everybody.
Beautiful workshop. Yeah, that's something that we're doing.
Right there.
Yeah. That's fine arts for you.
So there are actually not that many dependencies associated with systemd. You can imagine that if you do a more complicated service, this kind of chart gets crazy and hard to look at. But just even like this, it's a lot of the default dependencies and not even the ones we specified specifically. And then the other tool is like systemd-analyze plot, which I am not going to do, but you can run it on your own time. It will generate an SVG of the entire boot sequence, and it's like a multi-page visual of like how the time that all the units started. Any other questions?
Okay, we are gonna take 5 minutes breaks, bathroom breaks, relax breaks. We are present time. We are gonna finish here at 1 because of respect of people who work here and stuff. So keep it 5 minutes, and then we'll get back. Okay, folks, don't forget we still have some Portos pastries that you can go and take. Come and take, sorry. What is your problem?
No, it's the same problem last year. Mac and SCaLE Wi-Fi and VPN don't talk.
No, no, it's the end. Okay. I assume we are on the right time, so we are gonna finish this strong. We have about 30 minutes to finish. We're gonna do now the beautiful world of journal CTL, right? So as a little bit of introduction, besides of all the controversial part of System D also decided to replace like syslog and added the journal CTL. The values that it offers to people who manage system is really incredible, right? So you can still like not like it, that's up to you, but it is really good to operate on it. So we're gonna do a tutorial on it where we're gonna give you very basic dive into journal CTL. we have been using it a little bit, and then in tomorrow's, which is the advanced, we're not going to teach the advanced part of journal CTL, but commands are going to just show up on the tutorial. So it is nice. So without further ado, Anita will start this, and then I will finish it.
All right. So like Alvaro said, systemd comes with a daemon for doing logging, and it's called systemd journal D. The way you configure the systemd journal D daemon is with the journald.conf. It's stored under the usual places, /etc/systemd. And you can look at some of the commonly used properties along with their defaults in the example that we have in the GitHub here. We're not going to go into configuring any of them today, but I'll point out some of the popular ones, such as storage, which you can set to volatile, which will only store logs in memory, persistent, which will store logs on disk, auto, which will try and see which directory exists in order to decide if it wants to be volatile or persistent, and then none, where like we don't store any logs at all, we just forward them to wherever you tell them to forward to. There's also a global rate limit that you can set with the rate limit properties. You can also set per service log rate limits, so that if a certain service is too noisy, you can tell it to shut up faster. And then you can also set the properties on like how big your journal should be on the host. Skipping these, there's also the forwarding behavior, like I mentioned. You can forward to syslog, kmessage, console, or to wall, and they're all pretty self-explanatory. And you can also set the max log level of the messages that go to the journal using the traditional syslog levels or with the integers. So on a per unit level, you pretty much only have like 6-ish properties to configure how your unit gets their logs into journal. By default, all of standard out goes to the journal. You may not necessarily see all the output from standard out in the journal because of how the log levels are set, but you know, that's how it is. And standard error by default just inherits based on the behavior of standard out. And like I said, you can also set individual log levels in the service unit and also individual per unit rate limits for your logs. So enough about that. Let's look at some logs. So if you just run journalctl in your workshop setup, you'll get basically all the logs from the dawn of time, apparently, or when you last booted. And yeah, just a way for you to page through the logs and things like that. Pretty straightforward. I usually like to do journalctl-r. What it does is it reverses the log so that it shows the most recent logs on top, because I don't really care about the logs from like 2 days ago necessarily. I want the logs from right now. So that's what R does. And you can also use --since, give it some relative timestamps in order to be more specific about which logs you want to look at. So if we do --since, these are logs since 1 hour ago. In 101, we actually did the last 30 logs, so I'm not going to run that again here. And you can also use journalctl to look at journal files that you kind of imported or moved over from a different host. So we provided a journal file for you to look at, just as an example. I'm going to make sure it still exists. You can pass --file, and you can use journalctl to look at basically arbitrary journal files. This is pretty useful if you need to debug something. A user can just send you your journal file, to look at.
Okay. Okay. Cool. So now we can see a little bit how can you, as a developer, write to the journal, right? So we already saw that your unit by default sends their std in, sorry, so their std out and std error to the journal. We provide a small unit over here, and you can go and instead of start first, let's see what it has. Right? So as you can see, it's just saying standard journal, hello, and now we can start. And that will, if I do status, you will probably see that, yes, it is right there. Perfect. And now if I were to do your journal CTL, that's you will see that it kind of shows everything that goes into that unit. You can also see that it shows other stuff that are like from different PYDs, but these are all in the context of the unit. Give me a second. A thing that we didn't say, but we kind of explicitly have been saying, is that when you decided to add a unit in your commands, like here, you can do the unit with service or without the word service. So without the word without the dot service, it just appended at the end, right? So it's figured it out, right? The other thing that we didn't tell is that we have set up a tab completion. So if I do journal and then press tab, it autofill it. So you don't actually need to type the entire thing. This comes part of systemd. When you install systemd add-ons, extension, what's the name of the package that you install to get tab completion? Bash complete. I think it's come with systemd, and if you install bash completion, it comes. Yes, it just comes with systemd. Okay, that's moving on. Okay, cool. So that is one of the ways that you can print to the journal, right? So I also provide. We also provide here a nice script that you can look at it, and this is how you can write to the journal with. So if you look at that file over there, you can see that is importing PyStemd journal. We're going to talk more about PyStemd next, like tomorrow, but that's a Python interface to interact with systemd. And basically, we're going to say journal and send the variable, and we're going to send this message. We're going to set the priority, the message, and the syslog identifier for that one. So if I go here and just execute this script, like remember, I'm not even like, technically you're always in a unit. You can do that by looking at just like doing systemd status on the double pound, and that's your own PYD. You see that I'm literally on a unit, it's just a scope. But yeah, so if I go and execute this nice command, and then do grep for hello, you're gonna see that I had a message there from super unique ID, and then the ID, that's the syslog identifier, and then hello from PyStemd journal printing, right? So if you kind of see, that's the identifier that I have. So that's how you can like write to the journal from anywhere that you want. We already saw that we can do this by a unit. What we didn't saw is that you can ask for the output to be verbose. So this is also another interesting thing that the journal has that you don't see it everywhere else. You like, if let me not take. So you see that like this output is like text-like and the thing that you're used to. There is a bunch of metadata under the hood, right? So when I do verbose, you can actually see a bunch of more variables being set. So you can actually, like, since you can read this, you can do stuff based on whatever the message was or the login. You see, like, there's a syslog identifier there, but it also kind of tells you, like, what was the command, the host name, the message it says. It kind of gives you, like, the PYD and the command line that was executed, and you have the sysgroup and the unit from which this came, right? So there is a lot of information. So you can look, we already saw that you can look for unit, but you can also probably search by cgroup or any of these filters. Okay, cool. So yes, that's interesting. Oh yeah, we can also do this. Journal CTL PID1, and this shows you we are searching like we saw for filters. So we're using everything that comes from PID1. As we know, that's the init system, systemd. You can also do this. So look at all the messages that come from a unit, but from the PYD, right? So if I delete the PYD, sorry, this is going to be Marisa. If you see, like, there is a message that comes from the thing that was exec, but systemd itself add logs to that, saying, like, the things that it was doing. So if I just want to see that, because sometimes it is useful, you can do PYD1. This doesn't work, right? Yeah, it doesn't work. Okay. Okay, cool. Yeah, we have some exercises here that you probably can go and look at them. The first one is view the metadata from that file again, and you can see what files there was. We're gonna leave like 1 minute or two for people to do this, and then we're gonna do it ourselves. It was option. It was the file. What did I do? Oh shit! No, I didn't copy the file. I copied the entire text of the world. Okay, so and this. Okay, so as probably you already figured this out, you just need to mix everything, and then you can just do that, and then it will show you everything that was running. It's ask you, okay, so let's take this one. We can basically take that one and then say unit. And perfect. The PID was 333. Since you make this this part, am I right? Yeah, yes, I got Anita's approval. Okay, cool. So, any questions so far? No? Okay, great. So, let's do the last things, right? Journal CTL, if you do this mech, you get the message from the debug kernel. You basically get everything that you used to get with that one. Journal CTL list boots shows you the boots of the machine. And finally, this one is not a good example because it only has one boot, but if you do with HP, it just shows you the logs for the current boot. And that's the journal introduction. Go ahead. You can mix and match. Like, for instance, one thing that you can do is that like this one, you see has like file solution, but you can also add another unit, right? I don't know if systemd. Yeah, so like And it's fine, and it's gonna show you the journal. Probably UMD wasn't running on this one. But example, let's do it here though. There is journal. Wait. Yes, press U? You said? Okay. Yeah, okay. Believe me, it's somewhere there. Okay. That's the, yeah, that's the one. Okay. Go ahead.
So the echo command here earlier,
Mm-hmm.
it uses syndicat. Sometimes it logs as echo, sometimes logs unknown.
So the question was, sometimes you do system decat and it logs as echo.
Yeah, like at service itself,
Yeah.
it logs as echo.
Mm-hmm.
Sometimes logs as unknown because there's no actual service. It's
So,
writing from your terminal.
so there is a batch of so there is a bunch of things in play there when you're logging to syslog. The first thing is that systemd-cat and some things try to log as the main PID of the process, because like it's assuming that systemd-cat is not the one that is doing the log, so it provides zero information to say like, oh, systemd-cat is the one. By the way, this is what we're talking. So yeah, so systemd is this is gonna go and show and try to put stuff into the journal, right? But it makes no interest to say like, oh, is systemd-cat the one that is showing? So systemd cat tries to operate as the parent PID. If you are running as a user, like Nish, by the way, Nish, like whatever you start doesn't have permission to execute as another thing. But if you're running as root, you can. So systemd-cat will ignore itself and then will appear as the other. This is very common when you do systemd notify, which is the thing that we're going to look tomorrow. But yeah, so there's a lot in place. The other thing that has to be in place is that by the time journal D sees the message, the PYD that sends the message has to exist. So there is a race condition there where you cannot have attribution on the logs. It's a problem.
That's what's happening because
Yeah.
I sent a whole bunch of info questions.
Yeah.
Some of them showed echo, some of them didn't.
So yeah, so what Nish was saying is that he basically tried to do a denial of service on his journal CTL, and some of those messages got misattributed. Yes, this is something that happened. And I think we are done for the day. So who here has learned something new today? That is great. We're very grateful. We really appreciate that you guys came here. Thank you very much. And have a great rest of your day for the conference, and see you all tomorrow morning at same time, same place. Okay, so we have 15 minutes, and we have one more example. Do you guys want to see it, or it's time to go home? Okay, let's try. Okay. Disclaimer, we did this for Fedora 37, but let's see if it works. Okay, so the example is the following. Go into, so this is the one that we're gonna do. It's a workshop, analyze, systemd analyze, Nginx. So we're gonna do a thing that is called systemd analyze security. If you type this into your terminal, what this is doing, it's giving you an opinionated by systemd of how secure your services are, right? So the definition that systemd has for secure has a lot to do on, let me take a step back. So in the old days, you start your service, like you start an application, and this application or this service that is running start with the same privilege as you and inherits everything that you could do, right? It has the same view of the file system, so if you can write into root, the service can write into root, and all of those things, right? Today, this is not necessary, right? So if you have an application that all it needs to do is check if you have unfinished downloads, there's no reason why it have to be able to write into barlib, right? So you can actually hide a lot of the system, right? Maybe your application doesn't need to even see home directories, because like, why would you get access to your SSH keys to a random service? So you can actually hide them. So all of the things that systemd provide for you, if you don't enable them, it calls your system unsecure, right? Again, it's opinionated. Let's get past that. But you see, they have some services here, and we have a lot of them, and they have some data in them. Okay, so we're going to try to do one with Nginx, right? So let's do systemd analyze security Nginx, and it's going to show you all the things that it thinks are broken for Nginx, right? So it shows you all the properties that you can set that would change systemd, the Nginx behavior. And it has something that, oh, this is great, it has private TMP, right? So that means that TMP itself, it's mounted as a RAMFS, so Nginx doesn't have access to your host systemd. TMP just has like a shim version of it. So if one application store stuff there, Nginx cannot see it. That's kind of like the whole idea, right? Okay. So before we start, let's try to start systemctl Nginx. And you're going to see that it fails, right? And it kind of tells you, hey, execute this command to see why it failed. And it says, very not useful information. It says that it failed to start because it fails to open barlog Nginx error log, right? So what we're going to do is that we're going to copy the Nginx config, the previous Nginx config, and then we are going to edit that config to do in line 7. Line 7, we're going to change that error log. Sorry. Line 7, we're going to change this to be that. Basically, we're saying instead of like storing logs into a directory, because we actually want to like avoid Nginx to write into stuff, we're going to say just send it to syslog server, which is just journald. And then we're going to do the same thing for the access log that is on line 22. Looks good. We are also, why this keeps happening to me? We are also going to edit this Nginx unit, and we're gonna change the log directory to, this is another unit, this is another setting that is just gonna set a unit, a directory for the logs. Okay, and now we can start Nginx. Finally start, and then we can do a curl to port 8080, and if it returns okay, it's like we got Nginx to work. That was not part of the tutorial, that was just like cloudliness that it comes with the thing. Okay, cool. So now let's try to improve a little bit of Nginx. So we're gonna edit the Nginx, and now we are gonna add these following settings. These settings are actually kind of cool. What they make, and this should be on for most things. First of all, it makes private devices. That means that everything that is in your bar log that has to do with physical hardware, sorry, bar log bar dev, that has to do with physical hardware, it's not allowed for the unit to see it. Like for instance, like there's no reason why Nginx has to write directly into your CD-ROM, right, or your hard drive. So we're just going to say you're not even going to see an SD1 or an SD2. You don't need that. Private TMP, I already announced this. It basically, for TMP, it mounts a TempFS that nothing has access to it, and only Nginx has access to it, so there's no cross-contamination. Protect Home makes home, I think, read-only. I don't remember what True does, but there's options where you can like make it hide home. The other one is just make it read-only so that nobody can write it. And this one are other options that has to do with kernel. Like Nginx is not going to load a kernel model, so like why even like I'll give it the chance that it could do it. So all of this, right? So we save it. We restart it. We check that we can still query. And yeah, we can still query, so that exists. So let's see if we can analyze Nginx again. And we go to the end, and we now see that the overall exposure went up, right? So not exposure, but the number went up. Now we can do a couple of the fun ones, right? So we can see if there is a socket. So there is no Nginx socket file. And I just realized that we haven't actually looked at what socket files are. But we can go and create a socket file. And we have to say force full. Yes, so with these options, we will create a socket file, and then we can add this content. What this is going to do, it is very simple. So Nginx start as root, because it needs to open port 80. So instead of doing that, what we're going to do is that, Nginx start as root, open port 80, and then downgrade itself to whatever user you tell it to run. But we don't need to do that. What we can do is just let systemd start listening to port 80, and then when Nginx starts, systemd will just handle that file descriptor to Nginx. So that way, Nginx never even have to be root, right? So this is what we're doing right now. We're creating an nginx.socket. We're setting listen stream to port 80. We are exiting BIM. And then we are going to edit the Nginx. And we are going to add the following options. For the unit, we're going to do what Anita just told us to do, which is set up after on requires. And then we are going to add the following things to the service. We're going to say the type is simple. We're going to say that please don't rely on PYD files. We're going to set an environmental variable. This is the one that tells Nginx to read the sockets from file descriptor 3 and 4. And we're going to say private network so that Nginx cannot access other things other than this port, right? So Nginx itself cannot open ports. So if somebody hacks Nginx and can execute stuff, they cannot start listening to other that is not 80. So that looks great. We are gonna stop Nginx socket and service just in case, and then remember when Anita was showing you that you can start the timer and then the timer will start the unit or the path. This is the same, right? So we're gonna start the socket, not the service. You can start the service, but we're gonna start the socket. Now, if I do status on the socket, it says, oh, great, it is running, right? It's listening, all the information, nice. What if I say the service? The service, right now, you say that it's loaded, but it's not running. It's gonna run the first time that somebody hits port 80. It's the same as timer, right? So when timer gets to a time, it executes the service. The socket, when somebody hits the socket, is gonna start the service. So if I had eyesight, I could have done it. Then I could paste this, and then yes, And then as you can see, it took a little bit more the first time. And this is, of course, because it started service. You don't have to do it like this, but it's kind of useful because right away, because up until you actually require the service, you're not wasting resources on it. Question? Yes, so the question was, can systemd, or is there a way of preload the service before somebody asks? And the answer is yes, you just start the service and the socket at the same time. So where's the stop? Yeah, so you can actually start. Oh, actually, yes, so you can start it, and then the status of the service is up. So now whatever I do by curl should also be instantaneous, right? But it's still going through the socket, right? And if I understood Anita's tutorial correctly, I should be able to just start the service. And and by just the sheer magic of dependencies, start the service. Systemd so that you actually want the socket before starting the service. The beauty of the socket, it is like if you're not latency bound, you are saving a lot of resources by not having something running. Okay, so this was it. Okay, and I want you to see that we're doing all of this because we want to, there you go. We want to minimize that number here. This is the one that we want to improve, right? We're already improving it a little bit. So let's add more stuff. So now that we actually don't need to be root, we can just, now that we don't need to be root, we can just set these variables here. And what they all do is very simple. We're saying, yeah, just start as Nginx and group Nginx. Don't even think about being root. The only capability that you have is that you can bind to the network. And this here over here says, like, systemd will create some directories for you that you can use that you don't need to create, like bar run Nginx. Like, Nginx doesn't need to create this directory. It's already there by systemd. The same with the state, barlib, varcache, and etc, right, for the configuration. So now Nginx doesn't need to be able either to read or write this, to write these directories. So to create. Okay, we save it. Now we can go and remove the user Nginx from the here there is a line that says that the user is Nginx. We can go and remove that line. Yes. That's great. And we can also remove the line PYV, this one over there. We can go and delete the logs directories. We no longer need it. We can stop. We can start the socket. And then we can do analyze. And now we have a happy face because systemd really looks emojis, right? So the security just went to 4.8. Yes, that's still the case. And now if you really, really, really want to overkill it, we have like more options that you can go down. Again, we're 2 minutes. And I think that takes us to 4.0, right? So this is 4.8. If we do this, it will take us for 4.0, but how much secure you wanted to have it, that's up to you. But the point is that you get all this feedback loop of you add stuff, what it's doing. Keep in mind that this is one definition of security. It doesn't really have to be the one, but as long as you can still curl your service, and okay, that wasn't working. Let's assume it was. All right, but as soon as you can get your service to run, that's what you want. And on time. So thank you.
we had problems this morning, but they got ironed out for that.
Howdy. Can everyone hear me good? Excellent.
Hello, hello, hello.
That one sounds like it works too.
Okay.
Where's the on-off switch for this one?
At the very top.
Okay, perfect.
Yeah, so give it a second or two for it to come up. And just in case you're wondering, sound is only going to come out of this speaker.
Okay.
For some reason, I set the other speaker, even though that feed
Hello,
is
hello.
going to
Ooh.
record.
Oh,
I don't
that'd
know
be
why
fine.
I did that right here. Now, are these things yours?
Yes.
Okay. Yeah. All right, so
that's my
I'll be way back in
their trash. It's us. We're the trashing ones.
Okay, no problem. I'll be back in the corner during the presentation. I'm going to find out about the framing.
I think those are yours.
Well,
Probably not
they're for the
using them for
room.
this.
Yeah,
Yeah.
we can kind of stash them. Or do you
can
care
leave 'em
about
here
this
if
sort of thing?
Leave it here.
No, I mean, we've got 3 hours and,
that's usually the back of the room proctor thing.
right.
Not front of the room.
Yeah, yeah.
But that's when you've got sessions that need to stick inside of their
We'll probably finish early.
limit.
This is a
Yeah,
3-hour one.
we won't use
I
3
don't-
hours.
I don't think there's anyone following you today.
Yeah, no.
So we could run long.
Yeah.
Yeah, I don't want to.
Send out the beer or something.
Yeah.
Excellent. Thanks, Patrick. Patrick, right?
Names all the time.
Don't repeat them. I forget.
Hi, everyone. Thank you all for coming to SCaLE. I always enjoy being at SCaLE, and for coming to this. This is a new kind of format we've been experimenting with to do kind of an overview of CentOS and then a workshop so you can get some real hands-on experience with packaging and doing stuff in CentOS. So we've been wanting to do this. We've been wanting to do a larger presence at SCaLE for a while. So very excited to be here and doing this. So what is CentOS? Now I'll have more slides on what is CentOS, but we have a whole ecosystem. What you might refer to as just CentOS, the CentOS stream, that's the operating system that we'll talk about more, and that's kind of in the center of everything. But then we have all of these special interest groups around it. And you can see that I'm going to get a graphic designer to actually make this look pretty at some point, but I made this, so it looks terrible. You can see all of our, well, that's not even all of them. There are more special interest groups than that, but that's some of the more active ones that do various things, build different package sets, do alternative packages sets, other images and stuff around CentOS.
Could you introduce yourself?
Oh, hi. My name is Sean. I am the CentOS community architect, and here, I'll let Carl introduce himself.
Sure. Howdy, y'all. My name is Carl George, and I'm participating in the CentOS project, but also focus a lot on the EPEL project, which we'll talk about on another slide. I think the logo's up there right now. Yeah. And also, I'm not in camera frame, like I was just complaining about. Yeah, EPEL, this little logo here at the bottom. It's not part of the CentOS project, technically. It's part of the Fedora project, but very interrelated, and I'll talk about that more on the slide where that's appropriate. But yes, hi, I'm Carl.
Yeah, so I will also get a graphic designer to make it. I wanted EPEL on there because they're within the ecosystem, but they're not technically a CentOS SIG. So, so let's talk about CentOS Stream. CentOS Stream has a 5-year life cycle, 5-year and some months life cycle. There's a new major version every 3 years. And it is where you get enterprise Linux from. It is where RHEL is derived from, and any RHEL derivative systems ultimately come from CentOS Stream. It branches, I'm just speaking and not following the slides. It branches off of Fedora. So every 3 years we take a Fedora release and we make a branch point from that. And this year actually will be one of those branch years. So Fedora 40 will be coming out in a month or so. Like really soon,
Well,
right? So Fedora 40. Oh, okay.
Hold that thought.
I will hold that thought. Okay, so it's a long life cycle. We have a five-something year life cycle for CentOS. So there's about a 2-year overlap between when the current or when one version of CentOS, the new one comes out and the old one is still there. It is not a rolling release, even though that word has floated around even on some of our own blogs early on. I think people use the word rolling release to try to indicate it doesn't have minor versions, right? There's no CentOS 9.1, 9.2. It just has CentOS 9. But that's not what people think of when you say rolling release. When you say rolling release, people think of something like Fedora Rawhide or OpenSUSE Tumbleweed, right? Where there is no major release. It's just constantly getting updates, right? And that's not what happens in CentOS.
In CentOS, we have a major release, and it just gets updates within that major release, which is effectively the same kind of release cadence that you get on Fedora or most other distributions. They have a major release, and then they get stable updates onto it. Okay. Oh. And the updates that come onto CentOS Stream are stable updates. These are generally updates that you've already seen in Fedora, either the update itself, or it might be a backport of something that's already in a more current version, right? We maintain sometimes older versions of packages within CentOS Stream, so we have to do backports. But the features and the fixes that you see coming in are things that have already, that you've usually already seen in Fedora, and they've passed a bunch of gating checks and everything. So they're not experimental new features. They are stable updates.
I'll interject there. The way I describe it, I might have put it on the slide before, maybe. Yes, that last bullet point. I would call them RHEL style updates, where if you're familiar with how that works, we do a thing in RHEL called backporting, where the version of the software stays the same, but a bug fix or a security fix or something will get added as a patch to that older version. So like the software might be version 1.0, but then there's a security fix that came out in 1.2. But there's also a breaking change in 1.2. We want the security fix without the breaking change, so we take just the changes we need for the security fix and backport them, basically making a soft fork of the software. If the software ever got rebased like it does in Fedora Rawhide, you could drop those patches, but it typically, I don't want to say typically, there are some packages that get rebased in CentOS Stream. I know that the Rust stack, for example, moves very fast, and that gets rebased in every real minor version. So that'll get rebased in CentOS Stream first, a few months ahead of time. But for most packages, there's a strong preference to backporting things and keeping the same version for stability versus rebasing to a new version.
And the kernel is, like we stay on, I think we're on the 5.14 kernel. So we have 5.14, but it's like revision number 200 or something. Like that's how many backports get put onto it.
Into thousands.
Yeah. Let's do, I'm going to run the mic to them.
Test. Ooh, that's sensitive. Don't hold it too close.
Yeah, my question was, you don't update like the package version, right? But the only way you'd know the backport was done is to either look at the change log or to look at like the sources for the patch in like from the spec file list, right? Like looking at the spec file or.
Yeah, I can answer a little bit of that. Yes.
Yeah, go ahead.
That is sensitive, or I'm just really loud. Definitely the change log. Also, if you stay for the whole session, we're doing an RPM packaging workshop where I'm going to get into that in-depth detail. It's the field called the release. If you've ever seen the string for the package, it's like 1.0-5. That what I usually tell people is the first part before the hyphen is the upstream version, and the other number is the package version. So like the revision of the package. So the first one would be -1. And then you need to add a patch, and then it's -2, and then you realize you forgot to ship a file that's supposed to be shipped with the software, then you do that in -3, but it's all still version 1.0 of the upstream software is where you're starting from. That gets a little bit misleading when, like you mentioned in the kernel, where you're on like, -307, and because there's so many patches added, the upstream version is less and less relevant when you patch to that degree. But in a long lifecycle distribution like CentOS Stream or RHEL, it's unavoidable because you need to keep a lot of those versions the same for a long period of time. That cover it?
Yeah.
Definitely jump in with questions, and I'll come out to you with the mic.
Is
On
the
my way.
order, is the order Fedora first, then CentOS, then Red Hat?
Next two slides.
Yes. Do we have that on the? That one shows.
Okay, a couple slides ahead. Put a pin in that, and yes.
I have a sticker. Actually, I have. Here, talk about it.
Sure. I'll go ahead and talk about it since we had a question. It doesn't really matter what order we talk about these in. So this right here, can y'all see that laser pointer on the screen at all? Good. So a lot of people come up and ask, I thought CentOS came after RHEL, and I thought it was a rebuild of RHEL. And traditionally, that was true. In the past, we had the Fedora project. A version of Fedora would get taken internally private inside Red Hat and worked on for a year plus. and then all of a sudden kind of throw it over the wall open source that many engineers aren't a fan of because you're technically going from an open source project to closed development and then dump it over the wall open source. Like, people that care about open source know that that's flawed and don't like that. But that's how RHEL development worked in the past. It was all private development and then thrown over the wall. Ta-da, it's open source, but you can't really do anything with it other than use it. The CentOS project will come along and use those sources to create what we would call a clone or rebuild of RHEL. And I'm going to go back a slide to talk about that one. But that's not how it works anymore. The new model that is a lot more sustainable and more interesting for people that care about open source is that we have Fedora, and then it branches into CentOS. There's a period where it's like the early development and you probably don't want to start using it day to day yet. And then at some point we actually announce it as here, announcing CentOS Stream 10. And then about 6 months after that, that's when you see RHEL 10, which is, yeah. So here's how it worked in 9, a little bit more granular view. Fedora Rawhide is the true rolling release in this ecosystem. And the dashed lines are going to be like development. So you'll have, not right now, but Fedora 34 branched off from Rawhide, got a little bit more polish, and then released as Fedora 34, maintained for a set amount of time. Around the same time, we branched off CentOS 9 development, worked on that for a little while, getting more polish, and then at a certain point, RHEL 9 beta branched off of that, and then we did the CentOS Stream 9 announcement, and then a little while after that, RHEL 9.0, 9.1, and so on, branched off from CentOS Stream 9 development, or actual CentOS Stream 9. Things change a lot between here and here. We're getting things stable for the whole life cycle, which the RHEL engineers controlling those packages, they have to think about it, not just what we're putting in the next version of CentOS, but what is the business going to have to support for 12, 14 years, depending on the extended stuff that they sell on that side of the house. And that's what it's going to look like for 10. And we are actually right about here right now. We're in the last bit of the Fedora 40 development thing. We're about to break off the sync. We've already got the first initial composes to make sure everything works for CentOS Stream 10, but they're nowhere near the point where you should start using them. Once Fedora 40 is released, we're going to interrupt that sync. We're just using that to bootstrap things, and then independent development will happen for 10. Things like deciding exactly what version of the kernel they're going to use and exactly what version of OpenSSL is going to be used, things like that. That all is going to happen right around in here. But once we actually announce it as, it's here, it's ready, no one's ever going to say it's ready, but we'll announce it, and that'll be a good time to get on board and start using it. And that's around the time of the 5.5 years we mentioned. So going back to where we were before the great questions, keep them coming. Before I go on, was there any more questions about that kind of life cycle interaction and the branching? I know it's a lot of information dense.
So, can CentOS Stream be used in a production environment?
Totally. Absolutely. Many of us do use it that way. There's been a lot of I'll just call it a lot of FUD around that. A lot of people have tried to say, like, no, you can't use it now, it's too unstable, it's this totally different thing. But the reality is, if you actually look at it, the difference between RHEL and CentOS at any point is like 10%. Like, it's 90 to 95% the same software versions, may have a few extra patches, things that are, as you can see in the diagram, we're a little bit further back in time here, but what happens here in CentOS is what's being planned to go into RHEL 9.2. So it's not just it's not experimental. We have that on the not slide here. Yeah, it's not bleeding edge. It's not experimental. It's RHEL style updates. It's things that the business people want to put into the next RHEL minor version, and breaking compatibility would literally break contracts with customers. So that's not what's going to happen. Not that mistakes can't ever happen. They certainly can, but it's not just throw this against the wall and see what sticks. There's QA and stuff happens before it goes into the CentOS release. So I think it's great. You're talking about using it in production. You get bug fixes before RHEL gets them, and a lot of security fixes as well. So I think it works a lot better in that use case. One thing I will point out to people is that the traditional CentOS users that would use CentOS in like the first 5 years of the life cycle that care about those new features coming in the minor versions are a lot better. They like CentOS Stream, the new model, a lot better than the people that would use CentOS in the years 5 through 10 where they want it to not change at all, there's no more minor versions. Those people, and they want the 10-year life cycle as well, which CentOS doesn't have anymore. So those kind of people, there's going to be a preference to something like RHEL or something that tries to copy RHEL. But CentOS, for people that were using it in the first 5 years, it's still a great operating system, still the same major version, very similar software, and works mostly the same way. It's very functionally, it's basically the same. It's just the development works a little bit different. Speaking of that development, do you want to talk about contributions?
Yeah, sure. And I'll add to that. I think different people have different production environments, right? So for some people, like those minor release branches are very important. And for some people, they're not. Like if you're the kind of person who would have gone straight from 9.4 to 9.5 as soon as it comes out, then CentOS Stream is, perfectly fine. And if you're the kind of person that would redo your system after 5 years, which a lot of people do, but some people want these 10-year life cycles, stable minor branches or whatever. Ooh, fancy. So some of it depends on what your needs are in a production environment. Okay, so CentOS Stream. I think we kind of actually addressed a lot of this.
A little bit. We've hit around it.
Yeah.
Danced around it.
But some of the issues that we had with CentOS as a rebuild project, as a clone, is that you couldn't actually do anything, right? It was, people like to say it was bug for bug compatible with RHEL. And so if you were to file a bug against CentOS, the rebuild, saying, this package is broken, or my application doesn't work in this environment or something, if you could reproduce that bug in RHEL, well, then it's not a bug in CentOS, right? You need to go talk to Red Hat and get it fixed in RHEL first. So, so with CentOS Stream, we're actually able to fix bugs in CentOS as they're happening. And in fact, that's how RHEL bugs are fixed. Like if you're a RHEL customer, and you have an issue, you probably have an account rep or whatever. I don't work on the RHEL side of the house, so but you would talk to them. But it's all going to go through CentOS Stream.
Me neither. Y'all aren't talking to salespeople.
Yeah, I'm not
Neither
a
of
RHEL
us.
salespeople. I am a CentOS promoter. So,
And as someone, and I felt that pain a lot in the project, in the early pre-stream model and everything. I felt that pain. I would file a bug with the project and then run headlong into like, yes, we see the problem. We reproduced it on RHEL. So we're going to close this bug because our goal is to be bug for bug compatible. That is a frustrating experience from the outside, from the contributor, the reporter, whatever. It's also a frustrating experience for the maintainers on the inside, which later I became. For a few years, I was working directly on CentOS at work. And it's just a frustrating thing all around where you're just, okay, you can use it 100% as is. You can't really, you can do your own changes to it, but you can't get anything into the distribution for the greater good for everyone else, which that's we fixed the glitch in a way. Now, moving upstream of RHEL, CentOS can accept those contributions. The RHEL maintainers now maintain their packages in CentOS also, and to fix it in the next version of RHEL, the next minor version, they work in CentOS, do that. Everyone using CentOS gets that change first there, and then it shows up for RHEL customers later. RHEL maintainers also have the option to do stuff in older minor releases, but there's a lot more red tape for that, and that's, frankly, it's off topic for this, but it is sort of tangentially related.
I already did that slide. Oh, I have this as a sticker sheet. I'll put it out with the cookies
I'll pass
later.
them out. Oh, go back real quick?
Yep.
No. That's a clicker for the slides. If you
Oh.
One more. Yeah, not just the fixing the bugs ourselves. You can fix the bugs. You can actually do things. If you could report a bug and also say, I found this flaw, I identified the issue upstream, here's the commit that fixes it, and here's a pull request to add it as a patch to the package. And you can do all of that end to end, and the RHEL maintainer can just come along and say, yep, this all checks out, and we should fix this. We should fix this in RHEL and in CentOS, merge, and then they do their work to get it in the product optionally into the older versions, older minor versions also. But CentOS maintainers, who are now RHEL maintainers, are enabled to actually merge those contributions from the wider community rather than just closing down stuff as, can't change it because we have to stay the same. I'm going to pass these out.
Cool. All right. So that's CentOS Stream, which is, as I said, kind of the core operating system that everything else is built around. But I want to talk more about kind of the rest of the project, because CentOS Stream is a good operating system, has a lot of good uses, but I think some of the more exciting stuff happen with what we do elsewhere within the project. And so first of all, we have actually a board, and the board is to set strategic direction for the CentOS project. It is not supposed to be a technical governing board, except it keeps getting kind of bogged down in some technical things because we don't have other ways to deal with them, which I'll address in a second. So it's 10 members. They are kind of self-appointed. Whenever there's an opening, we have an open nomination process from the community, and then the board votes on who will fill that. We actually just went through this process. We had a board member step down, and we just went through the process of appointing a new one. So, and board members are able to serve for as long as they're, able to serve. People, come and go and get busy with other things in life. So, all of the board members except one serve as individuals, regardless of, who they're employed by. So, if you're on the board as a Red Hat employee, you happen to be a Red Hat employee, but you are supposed to be on there speaking for yourself and not speaking for your employer. And we have people on the board as well who are not Red Hat employees. The one, however, is Brian Exelbeard, who is the Red Hat liaison. And his job is actually to act as the voice of Red Hat to the project. So any of the other Red Hat employees on the board are not speaking
That sounds
for
so
Red Hat.
prestigious, the voice of Red Hat.
The voice of Red Hat. Brian with his glorious beard speaks for Red Hat. But he doesn't have a magic veto power. The whole board operates on a consensus model. So I mentioned that the board keeps getting bogged down in like these technical issues. And so a proposal that's going to go through soon, it's been through a few iterations here, is a SIG council. And this is basically a way for all of our special interest groups to speak to infra, to speak to the stream engineering team, and to have their voice heard, and to talk amongst each other, to say, oh, we've been having this problem in our SIG, or this problem over here, and to work together to solve some of their common issues. And this would be made up of a chair from each of the SIGs, as well as people from stream engineering and RHEL engineering. And they'd have regular meetings to kind of work through everything. So as I said, this is an open issue, but I want to bring it up because it's, I think, actually a really important development in the project, giving us more of a technical board, allowing the board of directors to be a non-technical strategic thing. Hey, Carl, do you want to talk about Apple?
I was just making a joke. I should go help with the presentation my name's on.
Apple is not part of CentOS, but I'm going to let Carl talk anyway.
Sure. So I think I mentioned this earlier on in the intro about working on Apple. Apple, I'm not saying Apple. A lot of people think that with my hick accent I'm saying Apple like the hardware, like the iPhone, but no, Apple or EPL. It stands for Extra Packages for Enterprise Linux. It is part of the Fedora project, not technically part of the CentOS project, but all related and friends, and directly works with CentOS, and I'll talk about that in a minute. Well, right here on the last bullet. EPL basically is Fedora packages that have been built to target CentOS Stream and RHEL, which is a little easier to explain with this little diagram I made. These are little boxes to represent packages. It is not drawn to scale. There's way more than like 100 packages in Fedora, I think like 60,000 last time I looked at it. But around, I think like 6,000 of them or so, well, basically, the slide earlier where I talked about branching off from Fedora, that's not all of Fedora. It's a subset of packages, basically the things that Red Hat wants to put into RHEL and support for the business, for customers. That subset goes into first CentOS and then into RHEL. Everything else in Fedora is eligible to be built in the EPL repo, and it basically just shows up like another Fedora release. If you're a Fedora package maintainer, I see a couple of them in here that I know. You have your package, and you have like the Fedora Rawhide branch at the front, and then Fedora 40 is the one we're working on right now. That's its own branch. There's a Fedora 39 branch, and so on. EPEL just shows up for the maintainer as another branch of Fedora, even though it's not, but it is. So that's how that works. It's a way for you to maintain a package in Fedora and then say, I use this on Fedora on my desktop, but I also want to use it on my servers. So I'll request an EPEL branch, build it, ship it there, and then it's built to be compatible with RHEL and CentOS. There's actually a really cool talk. I'm not going to take up too much time in this because this presentation is not about EPEL specifically, but the CentOS Connect we did at FOSDEM a month ago, I have a talk that's on the YouTube channel about that, where we're talking about the changes we're going to make for EPEL 10. And if you've used EPEL before or heard of it or interested in using any Fedora packages on RHEL or CentOS, I would encourage you to go look at that. We're going to do some interesting things. Because of a few different technical challenges, we created a thing called EPEL Next to work with CentOS Stream, but we're going to flip that model on its head in EPEL 10, and EPEL is going to immediately target CentOS 10, and then we're going to have minor version EPEL branches to target the RHEL releases. So that way, CentOS is a first-class citizen for EPEL packages rather than an optional afterthought that you might have to build for. So we're going to integrate it deeper and make it work a lot better, I think. But yeah, look on the CentOS channel on YouTube for that. EPEL 10 roadmap or some title like that?
Yeah, something like that.
EPEL 10 overview. That's the title. So,
Is it meant to be a supplement to,
Just repeat the question.
is it meant to be a supplement to RPM and Yum or just specialized for packages?
so EPEL is RPM packages, 100%. Supplement, I would still say it is a supplement because they're designed, in the name, extra packages. They're additional RPM packages for RHEL and CentOS, things that aren't in the base distribution. The first example that comes to my mind isn't a valid example anymore, but in the older days, I think RHEL 7, the only web server in the main distribution was the Apache HTTPD server. Nginx was not in the base distribution, and you could get Nginx from EPEL. That changed in 8. They added Nginx into the main distribution, so it's not a good example anymore. KDE is a good example. GNOME is the only desktop offered in the base distribution, but the Fedora KDE SIG also maintains KDE in EPEL for RHEL and CentOS users. That's a great example, old Nomi. Yes. Does that answer your question?
Okay.
All right.
And is there ever going to be a time where the EPEL will take on the status of primary and the RPM and Yum will go away, or are all three going to be active for packages?
Not as long as I'm working on it. I'm an RPM packaging nerd. I like RPM. EPEL has always been about RPM packages. A lot would have to change for EPEL to not be additional RPM packages, like so much that I don't think that's even feasible. I know that there's a lot of move towards what people call like the atomic stuff in Fedora, the immutability, but those are still built out of RPMs, and then there's RPM layering and other things like that. RPM's not going anywhere, and EPEL only has RPM packages. Any other questions?
What about modules?
Damn you.
For the RPM packages that you're talking about, are you also going to include modules in EPEL for 9 and 10, or is that not a...
You already know the answer to this, Jim. Ringer. So the question was about modules. You might have seen it before in Fedora modularity. You came in at just the right time, Neil.
Oh, I know.
Modularity.
Oh my God, we're talking about that?
Yeah, so it was Jim that asked the question, so he's trolling us lightly. So there was another technology. It was still based around RPM. The idea was that you could have parallel versions of RPMs in the same repository, and through a DNF command, configure which set of those RPMs you were going to look at, kind of like namespaces on a repository. The idea, I love the idea. The implementation left a lot to be desired. It didn't work very well. We actually did have an EPEL 8 modular repo for a while, but because of infrastructure problems we had with it and other things, and low usage, we eventually decided to just shut it down and turn it off. And so we don't have that anymore. We didn't do it for 9 ever, and we don't have any plans to do it in 10. And sneak peek, while RHEL 8 has a lot of modules, RHEL 9 has fewer, and RHEL 10 won't have any. So that is going away. That's an old technology. Don't really need to know that much about it. other than people that have been inside the project for a while, you can mention it to them to make them cringe.
Yep.
Any other questions related to EPEL? All right.
All right, so I mentioned special interest groups, and I'm just going to run through a few of them. I'm not going to give a status report on all of them. They are all supposed to give a quarterly update. We do a monthly-ish newsletter, so every month is roughly a third of the SIGs giving a quarterly update. So you can just watch the CentOS blog for those, and you'll see kind of what all the SIGs are doing. But I'm just a few of the more active SIGs. There's a new integration SIG. So I mentioned, everything that we do, all the updates that go into CentOS are tested. They pass a bunch of gating checks, right? And that ensures that CentOS Stream itself is never broken, the operating system. But you don't run an operating system just to run an operating system. You run an operating system to run your applications. And so the integration SIG has been working on doing further tests to test the integration of the operating system with various applications to make sure other people's stuff is not breaking with any updates. Even if the updates are non-breaking, sometimes maybe your application is depending on some obscure feature. I'm pretty sure there's an XKCD about this. So if you have critical applications, if you have critical applications running on CentOS Stream, you can work with the integration SIG to ensure that things keep working for you.
The way I'll describe that is, rather than coming along after the fact and saying, hey, you broke my thing because you changed, this maintainer changed a thing that they thought didn't affect anything in CentOS and RHEL, and it technically didn't, but they were building on it in a way that caused them to be affected. You can actually build in your own tests into that test suite and say that, hey, don't release an update for this package again unless my use case works. So it can no longer just be you're getting it as is. You can actually have a little bit of ownership and make it your operating system too, and say, this is the way this works here is important to me. Please don't release stuff that breaks that.
And I've got just some of the recent accomplishments. I'm not going to do a readout of these, but I asked some of the SIGs to provide some of this stuff. Hey, let's talk about the hyperscale SIG. Hey, Neil.
Oh, no. Hi.
You're only on camera if you stand here.
Okay. Michelle.
Oh, sorry.
Yeah.
Traffic jam.
Yeah, it's okay. So how do I put this thing on?
You want the handheld?
Yeah, I want the handheld. I don't want to figure out how to put this on. All right, so this is where I need to stand?
Yes.
Okay. I hope so too. So the hyperscale SIG, did not expect that. We do stuff around, I'm one of the leads for the CentOS hyperscale SIG. We do stuff around enabling CentOS Stream deployments and large scale things, like whether it's huge fleets of desktops and laptops, or even larger fleets of servers and cloudy things and containers and all the whole things. As part of that, we've done a whole lot of things in both CentOS Stream itself, contributing to the operating system. Again, as Carl mentioned earlier, it's about making it your own operating system, not just by adding tests to qualify that your stuff works the way it's expected, but also to change the stuff that's in CentOS Stream to benefit you and everyone else. So we've done some stuff here. If you're familiar in the Linux space about how Linux audio has actually shot up to be the best in the world, that's Pipewire and WirePlumber, and we did that along with making it pro audio work out of the box in CentOS Stream 9 and of course RHEL 9. And with SIG content, we do things like provide backports of various packages, including notably systemd. We provide Fedora-based kernel to add additional features that people want to do in the desktop and servers, container images, expanded virtualization and cloud images, and all this other stuff, all in service of being able to support our goal of providing people a high-quality experience to being able to use CentOS how they need to be able to use it, or want to be able to use it. I think that's it for the hyperscale SIG. So.
Thanks. I love talking about the hyperscale SIG because it's basically entirely non-Red Hat, right?
Yes. Well, there's one person.
Okay. But they're just like, okay, we could take CentOS Stream as a base and make something else that we want, because sometimes there's stuff that maybe we don't want to put in CentOS Stream, but you could make a very different system in the hyperscale SIG. And then sometimes some of those things do end up in CentOS Stream, which is nice. There's a KMod SIG, which packages a bunch of kernel modules, again for stuff that maybe we don't want to put in CentOS Stream for support reasons or whatever, but they package up a bunch of kernel modules for things like different file systems or supporting various pieces of maybe obscure hardware. But it's not obscure if you need it, right? So, they build a bunch of kernel modules, and they build them for both CentOS Stream and they build it for RHEL, and those RHEL ones should be okay for any of the kind of RHEL derivative systems out there. The alternative images SIG is another one of our new ones. So we have certain images that we produce, operating system images you can download and install. The alternative images SIG has sprung up to kind of create other images you might want to download. So right now what they've made are live images. They have a live image for GNOME, and then one for, am I handing it back to, oh,
No,
we're taking a picture.
Take pictures of this while presenting.
Neil is also involved in the alternative images SIG. But there's a GNOME and a KDE live image. So if you want to run a live image, there are images for that.
And KDE's the best.
We'll have words afterwards. But they're working on a lot of other images too. So you could imagine, say, images around that already have certain other special interest group content enabled right off the bat, so you don't have to kind of do that, like the hyperscale stuff. So you can get maybe a hyperscale image instead of doing CentOS and then adding hyperscale.
I see a few new faces. Did anyone not get the sticker sheet that would like one? I'll come bring you one.
I'll put them on with cookies.
Okay, yeah, we'll have him buy the cookies at the end.
You have to give it to Jim anyway.
I did. I chased him down to give him one.
Okay, good.
All right, almost done. There's an ISA SIG. This is also a fairly new one. And this SIG is investigating new CPU features. So the x86-64 architecture gets new instructions and stuff from time to time. All of the CentOS Stream packages right now are built on the V2 baseline. And the ISA SIG is currently investigating basically building packages with a V3 baseline, which allows it to use additional instructions in the x86-64 instruction set, which potentially can mean packages that perform better, and part of what they're doing is like, okay, let's build these packages with this different baseline and then run it through tests to see, is there better performance, and is it worth switching to that by default, which could, maybe leave off some older systems.
Sneak preview. I haven't seen anything publicly posted about those results yet, but talking to other people, I've heard chatter that at this point using V3 as a baseline for 10 is probably going to happen, like absent like a really big blocker that's like this particular customer is completely broken with that and needs us to be on V2. It's probably going to be V3 for 10. Sneak preview. Don't tell your friends.
A little late for that.
Are we recorded? We have an automotive SIG. This is very cool. So one of the things Red Hat is working on is an in-vehicle operating system. And they do all of their work upstream in CentOS. And so we have what's called AutoSD, which is it's basically a distribution of CentOS Stream, but tuned for these automotive applications. And that is the work that would feed into Red Hat's vehicle operating system. But it's something that you can play around with too, just in in the community space, and try to make changes too. So, oh, they gave me a diagram of their accomplishments.
Fancy.
I'm not going to do a readout, but you can see it. There's a cloud SIG. They're involved with building both stuff in the OpenStack and the OpenShift ecosystems. So the RDO distribution of OpenStack gets built within there. The OKD upstream of OpenShift, which is a Kubernetes distribution, gets built there. And they also build SCaLE, which is CoreOS is a Fedora image-based system, but SCaLE is basically CoreOS but built from CentOS Stream.
So, yeah, both.
Mike, click, go for it.
So one little parallel there I want to point out for the automotive SIG, what they all tell you a lot of times is that Auto SD, CentOS Stream Automotive Edition, or whatever you want to call it, is to CentOS as Red Hat in-vehicle operating system is to RHEL. So there's a parallel there. And that is similar to, we don't have the diagram here, but that SCOS thing, Stream Core OS, is to CentOS Stream as Red Hat Core OS is to RHEL. So it's the different variants of it, essentially. It's a minor detail.
And then this is the last one. These are, I put them all on one slide because these are 3 like non-technical SIGs. All the other ones I told you about were like doing testing and packaging and building images. And these are 3 SIGs that do non-technical work, which is a really great way to get involved. If you're not a packager but you like to use CentOS and you want to get involved, you can get involved in one of these. So we have the promo SIG, which puts on events. Carl mentioned we had CentOS Connect at FOSDEM last month. Or plans like our presence, here at SCaLE or managed social media, an artwork SIG that does artwork, unsurprisingly.
It's funny you said for people that aren't packagers, because I think that's what everyone's here for today, for the packaging workshop.
Yeah, well, you can become a packager or not. And then DocSig, which is oddly enough newly formed. We had a Docs, not a SIG, for a very long time, and then it finally got turned into a SIG. And there's a lot of work happening there. One of the cool things is actually all of the RHEL documentation is being developed in the open upstream, and we're able to use it for CentOS. We just have to do a little bit of work adapting it. So all of the kind of like the user guides and stuff for administrators, we can adapt to CentOS, but we have to kind of do the work in the community to do the adapting of that. And we're also working on improving the contributors guide, which is not great, to be honest. And there's various other things on here, and we have recently had archived the wiki because it had a lot of issues, but there's still some good content on there we want to pull out. So so those are those 3 SIGs. It's a good place to get involved if you want. Then are there any questions about that, or anything on here, or anything CentOS?
Can you maybe pull back the curtain a bit on kind of how, I guess, the people aspect of it? Like, are there people that work on Fedora and Red Hat Enterprise, for example? Or are they, once they take their curated packages, they don't necessarily communicate back to Fedora team, or how does that work?
So it's on one of the slides if you go back.
Yeah. The answer is it's complicated. I'm trying to figure out how to say it in a sentence.
It's a little complicated, but let me find the one I'm thinking of.
Isn't it the one that's on the Apple side?
No. Here we go. So I mentioned at various points talking about this that with the changes to CentOS, instead of just a handful of people rebuilding RHEL and calling it as is and can't fix or change anything, now we've blown the project up with literally thousands of more maintainers, because every RHEL maintainer is now a CentOS maintainer. So there's 100% overlap there. RHEL maintainers own their package in CentOS. Not every time, not 100%, but there's a lot of overlap with Fedora as well. So you have a package maintainer who is maintaining it in Fedora, and let me go back to they're maintaining it across the board from Fedora into CentOS and RHEL. Not all the time, sometimes it's different maintainers, but there's a lot of it, the case where they have the package, they understand it, and they're like, all right, this change in the software is only appropriate for Fedora, or this change is appropriate for Fedora, and then we're going to put it in the next RHEL major, which means the next CentOS major, or even discussions about putting the change into older RHEL minor releases and how they weigh that with different red tape internally and other stuff like that. But they have a good overview of the whole ecosystem and relationship on how that works. And not only that, a lot of these people got their jobs at Red Hat because they're involved in the upstream software project. So we're not just talking about packagers that know how the stuff works in Fedora, CentOS, and RHEL. They also interact with the upstream project. Sometimes they're in leadership positions in the upstream projects. Sometimes they started the upstream project. So they understand the software. They're as subject matter expert as you can get and understand the whole life cycle of it, and even understand, like, we can't make this change in the upstream project because of the downstream effects it's going to have in all these other places I manage it. It's not 100% with that. There are some things where there's disconnect, and those are always areas that when we find it, we're like, hey, why are you not involved in your upstream yet? And try to work to correct that. At the very least, get them involved in the Fedora packaging of it.
But you know, Fedora does make different technical decisions than CentOS. So CentOS is, people will sometimes say like Fedora doesn't have an LTS release, right? Sometimes people refer to CentOS as the Fedora LTS. And I guess it's about as close as Fedora has to an LTS, but it does have different technical decisions. It's not, we'll use Fedora 40 as a branch point for CentOS Stream 10, but it's not a copy of Fedora 40.
Some good basic, the most popular example people will talk about is that Fedora defaults to Btrfs as a file system. And that's a decision that there were Red Hat people that were not fans of that, but Fedora's engineering steering committee voted on that and said, yes, this is the way we're going to go for this. So Fedora makes independent decisions, and Red Hat can make separate decisions. Decisions, though, made in CentOS, though, directly reflect what's going in the next minor version of RHEL. So those will be things that Red Hat approves of. You're not going to see Btrfs in CentOS until Red Hat's like, yes, Btrfs is going in RHEL. There's less disconnect there, but a lot more freedom for Fedora to do things.
But you can get Btrfs and CentOS thanks to our special interest groups.
Two of them, actually.
Yeah.
The Kmod SIG has a Btrfs kernel module package you can install, and there's also the HyperScale kernel from the HyperScale SIG that has Btrfs enabled. So multiple options to do that. More questions? Don't feel like you're holding us up between everyone and cookies.
We have cookies?
Yeah, we have cookies.
I'm kidding.
For the alternative images SIG, do you guys produce other image types besides ISOs, like container images or QCOW2, or, and I guess like how do you build all those different images if you do support them?
So we could. No one's asked. So if you're interested in images that aren't live ISOs, come and talk to us in the alternative images SIG, and we can figure that out. At the core of it, the image build tool that we use currently for our images in the alternative images SIG is a tool called Kiwi. And Kiwi is a very versatile tool that was originally made by the folks in the OpenSUSE project to produce images of all kinds, whether it's containers or virtual machines or cloud images or disk images that auto-expand when you flash them onto real computers, or live ISOs. Right now we're using them to create live ISOs, but if people show up and are interested in helping to make more stuff, by all means we could. Fedora, as related to this, based on the stuff that's been going on in, you know, I know someone asked about the relationship between Fedora and CentOS in this regard. Well, HyperScale SIG and Alternative Images SIG, doing the work that they did to enable creating what I will call Red Hat family distribution images, that work fed into being able to do the change in Fedora 40, which is that they now use Kiwi to build their cloud and container images. So there's a symbiotic relationship, a very positive cycle of contributions that benefit both groups in a very obvious ways.
Any other questions here in the back while I'm here with the mic? Not a long walk. Just came back here to rile you up and get questions.
All right. Then in that case, we will do a packaging workshop. But first, we'll take a break for about 10 minutes or so. We can chat, socialize, and we have cookies and lemonade in the back. So enjoy the cookies. And
Don't break for too long. People will disappear and
Yeah.
not do the workshop. But yes, go enjoy the cookies and juice, and stick around to learn how to make RPM packages. All right, y'all ready to make some RPMs? All right. I'm excited. We didn't lose that many people, so I know a few people came in and out. It's fine. It's not going to interest everyone. I know some people mainly interested in the CentOS project overview. That's fine. Some people like packaging and scratches an itch in their brain, being able to deliver software in the native system format. I'm one of those people, so I like teaching this workshop. Yeah, Michelle and Neil, they're same way. It's not doesn't appeal to everyone, but I'm glad that everyone is here wanting to try it out and see if it's something that does interest them. This is going to be our RPM packaging workshop. I introduced myself at the start, but just again, for anyone that came in later, my name's Carl George. I actually work directly on EPEL that we talked about for Red Hat. Red Hat pays me to work on EPEL, not individual packages. The individual packages in EPEL are all kind of unsupported from Red Hat, but more just making sure that EPEL is healthy overall. That's my contact info. I'll put it up on the last slide too if you want it. This is going to be a hands-on lab, so I hope everyone brought laptops. Go ahead and open up that laptop and type in bit.ly/hello-rpm, and that's going to take you to a hands-on lab that we will run through for this. So the way this workshop is going to work is that we'll have some lecture, and then some hands-on, and then some more lecture, and then some more hands-on. I've tried to split up the lecture so I'm not talking just at you entirely, wake you up with some hands-on parts, but some of the lecture does go a little bit longer, and the last workshops are all workshops where I'll just, me and Neil's going to help me. We're going to float around. If you have a question, whether it's about the packaging stuff, in the technical stuff in the lab, or just the lab platform, if it's not working correctly for you, just raise a hand. We'll come over and help you out. I don't have a whiteboard anywhere to write down that URL for latecomers, do I? It's fine. If anyone comes in late, I'll just go back to this slide. So everyone present so far has typed in this short URL, right? Everyone that's going to. You don't have. If you just want to watch and listen, that's fine too. But the hands-on part is the best part of this lab. But first, you got to listen to me drone on geek out about stuff that I like. So. What is RPM? It is originally RPM stood for Red Hat Package Manager. They have since changed that to just not be an acronym and be RPM itself. Somebody told me that SCaLE did the same thing. Originally, SCaLE was Southern California Linux Expo, but to be more inclusive to non-Linux things, they're trying to unacronym that and just call it the SCaLE conference. So, fun fact for the day. So it's a recursive acronym, actually. Neil corrected me. It's not just RPM. It's RPM Package Manager, like GNU's, not Unix. So recursive acronyms. Recursive acronyms bug me, but anyways. But that's just the name. It is the package format for Fedora Linux, CentOS Stream that we've been talking about all day, or in this session, and Red Hat Enterprise Linux, and many others. It's consumed by package managers on your system like DNF. Whenever I first started using Linux, one of the things that interested me the most was this whole idea of packages, that rather than just going to download, ISI or exe files off the internet and run them on install them on Windows, having a central repository where you can just say, I know the name of the software I need, such and such, install such and such. That was just magic to me. I love that. Hooked me in, kept me using Linux, and eventually I was able to build it into my job doing package management things on Linux. So I mentioned it's scratching an itch for me. I like that part of it. I'm assuming everyone here has at least used Linux before. I think in the session we described it as basic command line familiarity is the prerequisite. So you've probably installed a package from the command line before. Why would you want to package with RPM? I know we had a question about other ways of like EPEL using RPMs versus other type of packaging technologies. You have all kinds of talk about things like Flatpak and Snap and other different methods for getting software in a system. RPM is a lot older, but the nice way to describe that is it's a lot more mature. It lets you easily install, remove, or upgrade software like any package manager would. It's got commands where you can query your installed packages and also verify the files from that packages are in the right place, have the right checksum, right size, all of those things. Each package, it's not just an archive of files. It is that, but it also has metadata inside, tied in with that archive to describe the package properties, and more importantly, the relationships with other packages. Each one of those packages doesn't exist in a silo by itself. It has its dependencies, it has things that it might conflict with, all those relationships. We'll get into those on a future slide. RPM also lets you digitally sign packages to verify authenticity, and you can distribute those packages in the DNF repositories like I talked about, formerly known as Yum repositories, still technically defined in etc yum repos.d, but that's... No. I'm going to call them Yum repos because they are. But anyways, one of my favorite parts about RPM versus other like system level package managers is that there's a concept of pristine sources. I don't have anything against Debian. I think they're a fine project. They do a lot of really good things. But one thing that bugs me about the Debian package format is that they have their system basically intersperses the packaging source with the upstream source in a Debian folder, and they manage them together. And when a new upstream version of the software comes out, they have to rebase their changes in the Debian folder onto the new upstream software. And some people like that approach. I think it's bonkers, and it doesn't work in my brain at all. I like the idea of separation of you've got the upstream source and the package source. And in the RPM docs, or at least in the there's a really old book online called Maximum RPM that it describes them as pristine sources, and that's a pretty good term for it. It makes it where when a new version of the upstream comes out, you don't have to do git repository management to rebase commits and patches and downstream changes. You just bring in the new upstream tarball and then try to build it, and if it works correctly, then you know you're good. It might not build correctly, and you might have to make changes to adjust for the new version, but most of the time you won't. You can just bring in the new upstream tarball as is without picking through the changes in it and build it with your packaging source, and most of the time get something out the other end that's usable right away. If anyone, I'm going to go semi-quick through this. If anyone has a question, go ahead and shoot up your hand and ask, and I'll come bring out one of the mics or see if Sean will do it for me. In fact, let me hand you that. It's off right now. Alrighty, so what actually is the RPM package itself? I mentioned before that it is an archive. It's got the files that are going to go on your system when you install it, but also metadata about those files. There are two main types of RPMs. You have the slightly misleadingly named binary RPMs that contain the files that are going to be installed on your target system. The naming around there is kind of the idea that you'd have like a compiled binary, but it's not exclusively compiled binaries. You can have binary RPMs that are what we call no-arch, where they are architecture independent. They're not a compiled binary. Maybe it's just Fedora wallpapers or a bash script. And it can be, because it's architecture independent, it's designated as no-arch and can be installed on any architecture, ARM, x86, 64, whatever. But the correct terminology in the documentation is binary RPMs, even if it doesn't have any binaries. Weird artifact of time, don't worry too much about it. The other type of type of RPM is a source RPM. Instead of the files that are going to be installed on your system, a source RPM has the software source code, that upstream tarball, like a tar.gz file, and also instructions for building that source code into a binary RPM. It could be as simple as putting that bash script in user bin, whatever, or it might be having to run compiler commands or all kinds of other more complicated steps. So I mentioned the recipe for building the package, or the instructions for building the package. That's going to be what we call the RPM spec file. It has a preamble section. It defines all of that metadata, and we're going to go into each of those one by one. And it also has what's called the body. It'll have various sections that'll define stages of the build process. This is also where we have like the changelog and other things like that. That's also part of the metadata. In that spec file, you can have conditions that give you the flexibility to use the same spec file for, say, Fedora and EPEL, like we talked about, how it's just another branch of Fedora, or multiple versions of Fedora, or multiple versions of EPEL, or even different operating systems. You could have one spec file that works and builds a correct package on both. These conditions are in there. We'll go into the format of those next or soon. You can also say that flexibility lets you do things like only apply this patch when building for Rail 8, not Rail 9 and up. Or only on AArch64, skip the test suite, run the test suite on every other architecture because it's broken on that one. Gives you flexibility for tasks like that. So inside the spec file, there is a thing we call RPM macros. That's going to be a variable that lets you do text substitution. The syntax, it's somewhat similar if you know bash variables, but instead of a $sign, a %sign right up there. And it has both with and without those curly brackets, and it actually is fairly similar to how that works in bash itself if you're familiar with it. You can use the macro without the curly brackets, but if you have anything else on that line that might get confused with the macro name, you need to delineate it and say the macro name stops here with these curly brackets, and then there's some other text. That's the real purpose for that. Both styles can accept parameters that will influence the output, because not all of them are just a straight, this macro has this exact string. Sometimes it is it can be Lua, the Lua language is built into the RPM package manager, so it is embedded. So you can actually do Lua things inside a macro that says, with this input, do these outputs and these other things. You can define those. I talked about having them in the spec file, but you can also define those on your system itself. The main locations, it's similar to some other software, like I think systemd made this a similar structure where you've got something under user lib that is like the system vendor level macros, and then you can have something under Etsy, which is like site local changes for macros that you want to make, and then you also have a user level one in .rpm macros. You can set up that macro. If you put a question mark there at the front of the name inside curly brackets, that'll make it conditional to only expand when it's defined. So if you have the dist macro defined, it'll put in that text there. And if you don't have it defined, it'll not do any string at all. Without the question mark, you would just get the literal characters % curly bracket, dist curly bracket. No, it puts the name of the thing exactly how you have it. Maybe that's a very new RPM thing. No, usually you get errors because like the %. Right, I know what you're talking about. Yes, so like if you have an unexpanded macro inside your build section, it's feeding that into a bash interpreter and says that no foreground control. I think %symbol in bash does some stuff with foreground background commands, so you get that error. But what it's literally doing in the spec file is just putting in that exact text of an unexpanded macro. And you don't want that. So if you want it to be optional, you use the question mark. Another conditional form is not just inserting the value of the macro, but to insert some other text. So you could say, like, if the rel macro is defined, insert the text -- disable this feature. Like, think like a compiler flag. You're passing that into the compiler. And so you can say, only insert this text if this macro is defined, ignoring what the value of the macro actually is. Like in this case, rel could be defined as 9, but if rel is defined at all, we're going to put in this text in that spot. You can also explore those outside of the build process. I think that's in one of the labs where you run RPM --eval or -E, and then the exact macro name, and that'll just evaluate that one macro by itself. You can also pass, for macros that take arguments, you can pass them along to it. That's why I have you don't actually need the quotes there for like a simple one like this, but if you're passing other arguments, you do need to put them inside the quotes so that bash doesn't interpret them separately. RPM --show RC, that one is going to print out all of the defined macros that your system knows about. Not any in a spec file itself, but all the ones that I talked about in those locations right there. It'll print out all of those together. So you could actually see that, oh, I've got this thing defined in my home directory, and this one's defined system level, and so on and so forth. So some of the really common macros that we'll have is file system paths. So like _bender is going to evaluate out to user bin. Datadir goes out to user share. Sysconfdir expands to /etc. which I always hate that one because what it evaluates to is shorter than the number of characters of the macro itself, but that's my OCD acting up. So yes, but still, Etsy with the macro around it is still longer than just putting /Etsy. But anyways, I digress. You can also do operating system properties, like the rel macro I talked about. That's going to be defined to the major version. Fun fact, since this is a CentOS classroom thing, rel is defined on CentOS also. So on CentOS Stream 9, the rel macro is also defined as 9. Because they're really dang close to each other, and I keep telling people of that, and not everyone believes me. Yeah. But either way, 9, so you can have, if you use this conditional, that is saying that whenever it's major version rel 9, do this thing, or insert this text. So the dist macro that I've been mentioning in a few places, that is a special one. We haven't talked about version and release yet, that's coming up, but this lets you insert the string .el9, and that makes sense later, but the short version is that when you're building, using the same spec file to build for, say, rel 8 and rel 9, the resulting package in the release field is going to end with .el9 or .el8 to indicate which thing it was built against. EL9 is literally, it's a little misleading. It evaluates to 1, but think of that in the like bash 1 true type sense. Like if 1, do this thing. More common macros are build process helpers. If you've been doing software on Linux for a while, you might have found a project that wasn't in your repos and you wanted to do a custom compilation of it. You might be familiar with the traditional dance of /configure, make, and make install. Real classic way, design around a make file. Those will usually take extra arguments to help shape where it is. Like if you just run those without any arguments, you're going to usually end up with stuff in user local, but that's not what we want for an RPM package. So we have these macros like configure and make build that actually pass in all of the predefined arguments distribution-wide to install things to the right locations like user bin instead of user local bin and GCC flags and other things like that. It's better to use those macros because you want to use the standardized distribution options for all of that compilation and installation and not just whatever you come up with on the fly that may not account for everything that's necessary. There's also the auto setup that is going to be related to before you get started doing the build process, and we'll get into the sections of that process later. The first thing you have to do is extract that tar.gz file from the upstream source code and maybe optionally apply patches that you need onto that source code. That's what the auto setup macro is going to do for you. Some more ones, what I affectionately refer to as the legacy Python helpers. They still work, they're still good, they're not that bad. But py3 build and py3 install, that'll correspond to Python 3 setup py build with some extra flags and install the same way. If you've done by hand installation of Python software, you might recognize that pattern. We have more modern ones now. They're in Fedora and also in CentOS 9 and rel 9. They're related to if you're familiar with Python projects moving from setup py files to pyproject.toml files, it's tied in with that. The pyproject macros can also find and interpret the setup py stuff. So in Fedora, it's better to always use those pyproject things. They work great in rel 9. They don't have all of the features in rel 8. There's some ongoing work to get those all backported and working. But there's also a thing in there called dynamic build requires that is not going to fully work on 8. Frustrating Neil very much. Other patterns you might be familiar with from other software, we have macros for CMake, for Meson. These are called, I think these are referred to as build systems, which is not the same thing as like a package build system like Koji and Fedora. Overloading of terms, it's frustrating and difficult. But yes, there's build framework.
There we go. I like that. We'll go with that.
I just decreed that's the new term. Yeah, but no, they describe themselves as build systems, I think. So yeah. There's also test suite helpers. There's going to be part of the spec file where you can actually run the upstream test suite. They're unit tests. Which one? These are just a few examples. No hecklers. Go.
That's my job.
So you've got some common ones. The PyTest maker will run the PyTest command with packaging specific options, similar with CTest and Meson test. So good. I get to take a break from talking at y'all and let y'all actually get to do some hands-on stuff and wake up. Right after this is the start of the lab. But what you're going to do in there, there's a tool, a command called RPM Dev Setup Tree. It's in a package called RPM Dev Tools. And that is going to set up several directories that the RPM toolchain expects to exist. In your home directory, you'll have RPM build, and then build RPM sources, specs, and source RPMs. And during the future labs, you'll see how each of those gets used. And that is the wonderful hands-on lab we're about to start. So that URL, did anyone need to see that URL again that came in later? No? All right. If you're just shy, just ask me and I'll come by and tell you the URL, but go ahead and load that up, click the start button, and follow the on-screen instructions. Unless you're an overachiever and already clicked next and started without me. Some people, there's always someone that does it, like I'm starting the first lab and they're like, all right, I finished all four labs. And I'm like, you're supposed to wait for the lecture goes with it and teaches you as you go. But anyways, if you have a question, whether it's the lab platform itself or the instructions in the lab, this one's really straightforward. I think it's just 2 commands. But after that, if you have any questions in any of the labs, just raise your hand. I'll come around. It's not going to be on mic. We're not shaming you in front of the class. No dumb questions, as they say. And I need to make note of the time because this one, we'll give this lab about this lab's quick, maybe about 5 minutes. In about 5 minutes, if anyone's still working on it, just raise your hand and I'll wait a few more minutes. But this one should be pretty quick for you. just an FYI, Neil here is going to be my sort of co-presenter helper. He's also going to float around and be available for any questions people have, anything not working correctly. So feel free to ask him or me questions. I think a few more people are working, so it's been 6 minutes, but we'll give it a couple more minutes just to make sure we don't leave anyone behind. Another FYI, this lab actually is staying online, I don't want to say permanently, nothing's permanent, but it's not getting turned off at the end of this workshop. So if you wanted to take this and do it again or share it with a friend, you can. I think the lecture that goes with it is really valuable, but I'm trying to make it where the lab itself has enough instructions for someone to just go in and do the lab with those instructions there. So like, for example, like a friend of mine didn't bring his machine, so if he's going to later on go to that same URL and do the lab, but just listen to the lecture right now. So that's also an option in case anyone didn't bring a laptop. I was hoping we had notes in the program about bringing your own machine. We didn't get any hardware provided, but I don't see it listed there. So either messed up or didn't print it in the right field or whatever. Quick show of hands, no shame if you're still working on it, but I just want to know if I should go ahead or wait a few more minutes. Is anyone still working on this lab? Got 1, 2, okay, 3. All right, yeah. We'll wait a few more, let people get all to the same page, and then before we move on. Just do the RPM dev setup tree stuff, hit the next, don't go on to the next part, because we have lecture that goes on with it. Stop being an overachiever, Sean. Only click next once. Oh, so you're caught up. Cool. Okay. Like the one time I did this lab at Summit, and during the first lab, somebody just had to tell me like, all right, I finished all like 4 or 5 labs, and I'm like, cool guy, like, good for you. You're first place.
In a contest that nobody was running.
Move on. Awesome. I think everyone that raised their hand said they're good now. Keep getting blinded by the projector. So, let's do a little more lecture. I got to bore you with my voice a little longer. So the lab we just did, that gives you the basic tooling that we're going to use. But now let's talk about the spec file format itself. So the first section is called the preamble. This isn't going to do with the build process at all. This is all about the metadata for the package, and that includes like package relationships to other packages, and we'll get into those. But for just the plain metadata fields, the name one, somewhat obvious. It is the name of the package. Usually you're going to pick that name based on what the software is called upstream. It doesn't have to match the upstream, so you could do it differently. Simple example, the upstream might always capitalize their project name, but in the package you want to make it lowercase. Yeah, there's lots of ways to go about it. I think the Fedora packaging guidelines have a preference to lowercase everything unless the upstream project specifically asks to keep a certain capitalization, which is fine. But there's lots of flexibility there. But yeah, it probably will match something upstream somewhat, just so people know what the package is. But what it does have to match is the file name of the spec files. So if you're packaging foobar, your spec file needs to be foobar.spec. The version of the software, that is going to be, I think I touched on this in one of the Q&A questions earlier, but the version, that's going to correspond to the software's version upstream, what they release the version as. The release is basically another version, but that is the version of the packaging you're doing. And you use that separate version to distinguish between different builds of the same upstream software version. And I'll show that in some of these examples. But these three fields together, name, version, and release, they form, around like the Fedora project and other places that deal with a lot of RPMs, you'll hear the term NVR thrown out a lot. And that literally is the name, version, and release jam-packed together. And that forms a really useful identifier. Like if you're explaining in a bug report what version of the package you have installed, typically you'll use that NVR full identifier, not just the version, the upstream version by itself. Here's some examples. GNU awk package is named gawk, and then you've got a hyphen, the upstream version 421, and then another hyphen, a 4.el8. That .el8, that is the dist maker we talked about earlier expanded to that. So when you could build the same spec file, and you'd get all of that .el8 and then all of that .el9, two separate packages built for different like GCC lib and other things like that. Not GCC lib. glib2 is what I was thinking of. Different libraries, they'll build for the different, that indicates the target you've built for. You can't just do the split on the hyphen though, because package name, it's also valid to have a hyphen in the package name. I'm getting ahead of myself here, but you can have a package name vert what with a hyphen in the middle, and then your version and your release field. The way I'll do it if I'm doing something custom in Python for like parsing this is Python has an R split from the right, and then two fields. So from the right to the first hyphen is the release, and then from the right to the next hyphen is the version. Everything else is the name. And the one in the middle, that's just showing. What's that?
I can't believe I've never thought of that.
Yeah,
before.
Python's string.rsplit.
Yeah, I know, but like.
rsplit 2. Anyways, and then the middle example, I just had that there to show some different versioning. Some projects use like this, I think it's called like octets, like something dot something dot something. There's a terminology called semantic versioning that looks like, and I would not ever trust that an upstream is doing it just because it looks like it. Semantic versioning is a really good system that a lot of projects use something that looks like that superficially that doesn't work like semantic versioning rules at all. You might you might look at that and say like, oh, I understand that there's the major version and then like the feature version and then like the bug fix version. And that is what some projects do. That's close to like semantic versioning. It's a whole schema, I guess, or like standard. And it's great. I love it when projects actually follow it. A lot of them don't. For example, Python, love me some Python, but Python, the first two digits are basically the major version, like 3.12 or 3.13. Right. First two octets. Yeah. They're not digits. Because that's something to point out. Version numbers aren't really numbers. They're strings. I had this conversation at a previous employer with someone. They were really bugged about the fact that like something.10 evaluated differently than something.2. And I'm like, well, because it's a string of 10, not a decimal of .10. Yep. And so, yeah. And because upstreams do all kinds of different versioning, like you might have something like the TZ Data project that releases 2024A And that's not alpha, that's just A, and then B, and then C, and then D, on and on. Yeah. You might also have alpha and beta identifiers inside the version string. There's all kinds of ways upstreams can do this. RPM has pretty good logic on around evaluating that. It has to understand that so it understands what RPM is an upgrade for which other RPM. But there are still things that can throw its sorting out of order, and we'll talk about that with this wonderful thing called epoch, or epoch. This is a third version field, and what it's used for, so the fourth? The name's not evaluated for the version comparisons. This is the third one. So you've got the version and release that I talked about, like the upstream software version and the package version, sort of the release that you're doing of it. But let's say you have an upstream project that decides that we were using versioning of 2024.01, but we don't like that anymore, and we want to switch to proper semantic versioning. Hooray, everyone loves this. And now we're going to be version 1.0.0 for our next release. But RPM's evaluation is going to look at those octet by octet, or section by section, and say that 2024 is bigger than 1, therefore this one on the left is a higher version, and 1.0.0 is not going to show as an upgrade when you do like a DNF update on your, or DNF upgrade on your system. Epoch is a bigger hammer. It is a super version in the spec file where you can say, I don't care what the default sorting is, this thing with an epoch is bigger than this other thing without an epoch, or with a higher epoch. No epoch is basically an implied 0 epoch. Normally you wouldn't have to, you don't have to put epoch 0 in your spec files. You normally shouldn't have to touch this. It is few and far between where this is actually needed. Some people make mistakes, and I've seen it before. Some packages you'll see in Fedora and CentOS and RHEL have a really high epoch, like 70. And there's no way that an upstream project has changed their versioning in a non-sorting way 70 times. It's just not. But there was, I forget which pack. I think Perl has something like 40 or 50 epoch. But there's historical times where someone mistook the role of epoch in release, and they were bumping the epoch every time they made a packaging change, which technically works, but it's like a misuse of resources. Yeah, stuff like that. So usually it's a mistake when it gets to a really crazy high versioning. More likely you'll have just a no epoch at all, or an epoch of 1 because one time the project made a non-default sorting version path. It is also possible that you might need to use, I had to use an epoch the other day. I switched a package, Python docop. It's basically dead upstream, hasn't been updated in like 6 or 7 years. No responses from the maintainer. It happens. You know, sometimes people, let's say the lottery factor. People talk about the bus factor, which does actually happen, sadly. My manager tells me use lottery factor because that's a lot more positive. Yeah, it's a lot happier. Yes, but they haven't touched the project in a while. That's fine. Somebody made a fork, and somebody asked, hey, for this package, can you switch it to the maintained fork? It's a lot of people involved, standardizing around it. It's great. And I was like, this makes perfect sense. I've done this in packages before, switching to a maintained fork. But I didn't realize that with that switch, they didn't keep the Python metadata name the same. They actually switched it from docop to docop ng, corresponding to what's on PyPy, the Python package index. And so that change caused some unintended side effects with the upgrade. And so I was able to go from, I think it was from version 6, I upgraded it to version 9 in the fork. And then I realized this is actually broken and not compatible software. I need to undo it. So it wasn't an upstream mistake or change. It was my mistake. And I was like, I need to actually force the upgrade path to go from 6 to 9 back to 6. And I did that with an epoch. So now epoch 1 version 6 is higher than version 9 without an epoch. That's what it's for. It's just a really big hammer that you should save for last resort, break glass type scenario. We won't have to use that in this lab, and you almost should never have to, probably not have to use it, but it's good to know that it exists if you need it. I hope you never use it. Yes. So, also in the spec file preamble, we're going to have these other fields. The summary is exactly what it sounds like, short one-line thing. You'll get, we also, during the lab, you installed a package called RPMLint. We'll use that later in future labs, but it'll complain if your summary is longer than, I think, 80 characters. So you want to keep that fairly short. a lot of upstream projects will have like a short description and a long description. The summary would correspond to the short description from upstream a lot of times. But this is up to you. It's just how you're defining it for the package metadata. How you want to describe it, how you want it to show up in like DNF search or DNF info. The license, that is going to be an identifier for the license of the software, like MIT or Apache 2.0, things like that. Small note on the license thing. Fedora is in the middle of a project to standardize. We had our own system for a long time because there was no standard for short identifiers. There is now. The Linux Foundation's backed a thing called SPDX, and Fedora is standardizing on using SPDX identifiers across all of our packages. Still work in progress. There's a lot of packages. RPM lint in CentOS 9 and RHEL 9 doesn't understand those identifiers yet. So in the lab, for the sake of not getting an extra linter error, we're using the old identifier. But if you start getting involved in Fedora packaging, know that those identifiers are technically wrong now and against the guidelines. Coincidence. Neil said that MIT is right on both because the legacy identifier and the SPDX identifier for MIT is literally just MIT. Yes. Unless you're using one of the weird MIT variants that used to be called MIT that is not MIT by itself anymore. Anyways, that's a tangent. You've got packagers like geeking out on stuff. But anyways, so summary license, URL. That's just what it sounds like. It's a URL where you get more info about the software, either a project's homepage website or the GitHub repo or GitLab repo, whatever you want to call it. Just where you would go to get more info. The homepage of the software. Build Arch, that is, I talked earlier about the binary RPM name being a little misleading. Build Arch, normally you don't have to define it. It's going to be defining your packages you build based on what architecture you're building the packages, the system you're using to build them. But if you want to build a no-arch package that is valid on anything, like say wallpapers or bash scripts that are architecture independent, you can manually set build arch, no arch, and define it that way, and then you'll get a package that isn't designated as specific to particular architectures. That would matter, like, let's say you're packaging up a bash script and you're just putting it in user bin, and then the resulting no-arch package you want to be able to install on both your AArch64 systems and your x86-64 systems. If you skip defining this, you get a package that only works on one or the other, arbitrarily set in the metadata, even though the actual contents would work on both. So this is the way you make it. You actually identify to the package itself that you can work on multiple architectures. You don't have any architecture-specific files. More preamble sections. The source. This is going to be a file name or a URL to a file that you need to build the package. This is where the first one you'll see usually is the source code archive link, like a GitHub download URL, or like if the upstream project has their own file server they publish their archives, their tarballs under, you could use that. You could also use it for things like a default configuration file that maybe it's just locally with your spec file, maybe it's at a URL somewhere online. It can be either one. Then you also have patch tags. These are similar to source. It's either a file name that you have right there alongside your spec file or a URL to a patch file that you're going to apply to the source code to make small changes. You can use both of these tags multiple times and optionally suffix them with digits. In Fedora, so the suffix with the digit is actually mandatory on RHEL 7 and RHEL 8, I believe. RHEL 9, it's not. You can use unversioned. It's a little slight. I think it's a little cleaner to use the unversioned one, and I would only mess with the version source and patch if I had to specifically do something with one of the sources or one of the patches. If you've just got a source tarball and 3 patches, you don't have to number that because that can all be applied automatically. If you want one of your patches to only be applied like on AArch64, then you might want to number them so you could say only apply this specific patch number, things like that. So now getting into the more important type of metadata, I think, your package relationships. So the first one is build requires. These are going to be packages you need in order to build your package, also known as build time dependencies, as opposed to requires. That's going to be packages that you need to install this package, or runtime requires. Good difference there. and it's important that those are separate fields. Some people say like, oh, well, anything that is required, I'm going to have at build time, and that's not true. You can have runtime only dependencies that aren't necessary to build your software in any way. So you have control there, and it's a little duplication if you have a long list of dependencies, but it's not that bad. It's better to have it a little bit more explicit, I think. Recommends is a slightly newer one. I believe it works in CentOS 8 and 9, but not 7. Of course you remember the exact version it was introduced in. But yes, recommends, it's what's called a weak dependency. It functions like a requires, like a runtime dependency, and it'll be installed by default. But the difference is that you could actually remove it and not remove the package that had a weak dependency on it, making it an optional dependency. You could also configure your system to skip the recommends and optional dependencies anytime. Supplements is really cool. That is what I call a reverse recommends. There's no requires equivalent to it, but basically with the supplements, the example I like to give is, think you have a piece of software and then you have plugins for that software, and those plugins change over time. You package new ones, add them, you might remove some. If you use recommends for it, the main software to pull in all the plugins, you'd have to enumerate all of the plugins in the main software spec file, and then if any of them change, update that list of recommends in the main spec file. Alternatively, you can use supplements and have every spec file supplement the main package, and then if you remove or add a new package, you don't have to update the main package at all. It's because it's working in the opposite direction. It's saying I'm an optional dependency for this thing, and it just gets pulled in and recognized. Conflicts, that means packages that can't be installed at the same time. It's better to avoid this one if you can, but sometimes it is unavoidable, kind of like the epoch thing. Usually where this will come into play is file path conflicts. You might have two completely unrelated software programs that both install user bin foo, or user bin convert, I think, is one that's we have to deal with. That this software has it, but this other software completely unrelated also has it, and neither upstream wants to rename their program, but there's a namespace collision. So the only thing we can do, if you don't do anything, DNF will let you try to install them. It'll start that transaction, and after it's downloaded the RPMs and tries to install them, it'll abort and say, I actually can't install these because they both have a file at this spot, and that's not going to work. You can tell DNF ahead of time that these two packages can't be installed at the same time with that conflicts directive, so it will actually tell you before it downloads those RPMs. It'll look at the metadata, say, nope, these two conflict, and that breaks the transaction. You can't install them at the same time. Maybe more common example than just an accidental name collision would be forks of software. You may have one software and then somebody else forked the software. They changed the name of the project, but they still have the same command. And then maybe it was a contentious forking, maybe not, and neither project's like, nope, we are owning the name, or even we have to have this file path because the way the software is written, it expects this in every artifact of this other thing. Different real world examples I'm bringing up, but in the end, you can make those two packages conflict with each other, so that way DNF understands that they can't be installed at the same time. Obsoletes, that is a relationship where you're telling the system that one package is going to replace another package. That might be used for if you're renaming a package. Like let's say, I know this isn't how it worked, but let's say you had a wget package and you wanted to replace it with the wget2 package. I know Neil's wants to jump in because that's not how the wget2 project worked. That's not what it was. But anyways, if you wanted to replace one with the other, you could use the obsoletes in the second to say this is going to replace the first package. Sure. Eventually it will. Okay. So yeah, so Neil brings up the fact that the DNF project itself is undergoing some changes where DNF itself is version 4. They've been working on a new major version 5, but the way they're doing it is basically putting 5 in the project name and in the binary name, and they're going to have symlinks. User bin DNF is going to be a symlink to user bin DNF 5. but it is also at the same time replacing an older project called microdNF that was used in containers. It was basically a DNF with no Python dependencies that could only install packages. I don't even think remove them or do other more advanced stuff, but super lightweight, great for installing stuff in containers. DNF5 is part of DNF5, the DNF5 rewrite is to remove the Python dependency. The rewrite mostly in C++. There's still some Python stuff, but the core executable is going to be slimmed down and replace the functionality of microdNF entirely. So they're having DNF5 obsolete microdNF. That's a good real-world example of it. Provides is another relationship. This one's cool. It lets you allow other packages to refer to your package by another name. And that's kind of a vague way to describe it, but the real-world example to make it concrete is you could have a package that needs a web server installed, but you don't care which web server. You just need a web server. You want a web server to be installed for this software. You could have web servers in Fedora and CentOS actually all provide the name web server. So the HTTPD package, the Apache web server, provides web server, just the name web server. Nginx provides web server. Caddy provides web server. So you can have another package require web server and have that dependency satisfied by any of the other web servers. Doesn't matter. If you don't already have it installed, I don't remember how exactly it picks one. I think it might pick the one with the highest version. Okay, yeah. It lexicographically does alphabetically on the name first.
Yep.
At one point I thought it picked the one with the highest version, but that's not correct.
That doesn't make sense.
Neither does picking one by first alphabetical either, but
Yeah.
A web server. Yes, but it allows you to have install the web server first, or in the same transaction explicitly name which web server you want to install, and then that package will provide the web server name that satisfies the dependency of the other thing. So that's where provides come in. It also comes. I'm not hitting everyone. I've legitimately never heard of that. So I'm up here learning things as I'm giving it. Apparently there's one called build conflicts, and I'm going to have to look into that later because it's not a RPM 101 level thing.
The thing you gave as an example for requires, for conflicts at runtime, where you have like multiple providers, the same thing, but you know that one is not good, can also apply at build time. Because, like for example, a good example of this is the user bin convert, as you started and stopped with, is owned by ImageMagick, GraphicsMagick, and like 4 other different things. But like, they changed only in our package. Upstream, they still do user bin convert. So yeah, no, you get to have fun with that. But if you wound up having a situation where there's multiple theoretically identical providers that are actually not, you need a way to tell it not to pick that. And so build conflicts is the way you do that. So the same way you tell it to not pick something at runtime, you can also tell it to not do something at build time.
I would just do an exact build requires.
You should hopefully never need build conflicts.
Yes.
But it is good to know that it's there.
More advanced things. And this is not going to be conclusive, all of the possible tags. If you are interested in those, rpm.org has the full docs for every possible thing. This is entry-level 101. So no more obscure new things for me. Don't make the presenter look bad.
Sorry, this might be an obscure one as well, but do you, in CentOS, do you have to care about multi-lib conflicts as well? Like 2 packages, like 64-bit and 32-bit, and you try to upgrade one without the other, and then you get weird conflicts.
So I don't know a lot about multi-lib. I'm sure I could hand the mic to Neil and he could talk for 30 minutes about it, but we're not going to do that. Yes. Multi-lib is a thing where it's specifically for libraries, so that way you can have both like a 32-bit and 64-bit version of the library installed at the same time. I think for the most part, those get the conflicts worked out automatically because there's user lib versus user lib 64. So I think most of those are just resolved by being in a different parent directory. Yes, data files in common could cause a problem there, and I don't know how that's resolved in multi-lib actually. Let's talk about that more afterwards. That's beyond. good question, beyond the scope of this workshop. Yes, let's just get rid of 32-bit. That solves the problem. All righty, so more fields in the preamble. We've got the description. I mentioned before that some projects will have like a short and long description upstream. This is where you'd put the long description. It can span multiple lines. It can be multiple paragraphs if you want. Doesn't really need to be that long. Really the target for this is when someone does, if you do just like DNF search on the command line, you'll get that short summary listed next to the package name. If you do DNF info on the package name, you'll get the summary and the longer description. Some software doesn't really describe their software that much, and so you just use the summary with a period at the end for the description. Yeah, or make up your own. A lot of times I'll try to get like the first paragraph of the upstream README, or maybe massage it down to the first few lines, something like that. But it's whatever you want it to be to describe the package in DNF info output, basically. And then a little bit more advanced thing that you can do is what's called sub-packages. You might have seen this before if you've seen, I'm trying to think of a simple library. Let's say you've got libpcap, and then you also have a libpcap devil package. Those are, it's the same software, but you're splitting up the development files into one package and the main library files into the other package. Some distributions keep those all in one package and get bigger packages because of that, but in RPM, it's standard practice to split those things up for the use case because everyone that needs the library present doesn't need all of the development files present. So you would have a devil sub-package where you place those different things, and you control that by adding a package and description section in that preamble. And each of those, the package one starts a new preamble, and then the description just goes along with it. So you could say these are the development files that go along with this, and it has this other runtime requirement you have to have installed. The name there, one interesting note, that's not going to be the full package name. Right there in that format, if you just put a name there, that'll be appended to the main package name, where you have like foo and foo-devel. You could also do an arbitrary name completely separate from the main package name if you add the -n flag in the middle there. So you could say like you have package foo with a package bar as a sub-package, and it's not immediately apparent that they're related because it's not a suffix. So you usually wouldn't want to do that. You'd have your sub-packages named with just the suffix there. That's a little bit more advanced. I don't remember if we have that in the lab or not. Oh, we do, I think, for the Python lab. No, actually, I take that back. No, the Python lab doesn't have that. So you won't see that in the lab, but it is good to know about. And if you've seen those type, like development packages or separate packages like that, that's where that comes from. That's how you define that. So the spec file body. This is where we really get into the meat of the build process. The prep section, that's going to be where you unpack the source code archive, the tar.gz file. You need those files extracted, and then you would also apply any patch files to those. Like, let's say you have a patch that changes, fixes a bug from upstream or adds a fix for a security problem. Anything like that, you're going to be applying that during the prep section. And we have that helpful auto setup maker I mentioned earlier. Will apply all of your patches for you without you having to manually go through with the patch command. It's really useful. The next section is build, and it's exactly what it sounds like. That's what you're going to run to build the software. Those helper makers I mentioned earlier, like make build and make install, those would correspond to the build, and the next one, the install section. Whereas build, that's where you're compiling the software usually. Install is where you're going to place those built artifacts into a directory tree that it was called what we call the build root, but it's going to be simulating the file system structure on the target system. So inside your build root, there'll be a subdirectory, user bin, user lib, all those things, and you'll place those files where they need to go in that subdirectory structure, and then that becomes the top level structure in the target system when you install it. And then finally, there's a check section. That's not exactly building the software, but that's where you can run any kind of commands to test the software. Upstream unit tests work really well here. You might want to do like a functional test where like you run the command and check for some kind of output. Really anything you want to test the software functionality. Two more. I think we're going to get to the lab soon. The files section. Files and changelog work differently than those other sections. The prep through check section, those are basically bash scripts. These ones, files and changelogs, these are text and in a particular format. The files one, that is a list of the files that are going to be installed on the target system, like user bin foo and then user share doc foo, whatever files you're going to have on the target system, you just list those, the full path to those right there. The changelog, that's in a specific changelog format. You'll see it in the lab. That's where you're going to record changes that have happened to the package between the different versions and the different releases. You don't have to be overly verbose there. It could be as simple as updated to the new version. I've seen some packagers where they try to jam in the entire upstream changelog in there, and that's not what that's for. Fedora package guidelines actively discourage against doing that, or might actually forbid it now that I remember it. Yeah. Yeah. It should be fairly short. You could link to an upstream changelog, things like that, but it's more if someone runs, RPM-Q -- changelog on their system, what do you want them to see? Do you want them to see 1,000 lines of upstream commit messages? Probably not. You want them to see like, hey, there's this new upstream version and I added this sub package, or I patched out this problematic subcommand or plugin, whatever. Things that would be relevant to the end user immediately. Sure. Neil. Sure. I was like, where's my mic runner? I got a lab helper and a mic runner.
For the files macro, is there a way to automate a long list of files that need to be installed? Let's say your make outputs 100 files or something like that.
Yes. Yes. There are lots of ways to do that. So I know, for example, in the file section you could do, we haven't talked about this slide yet, skipped ahead. So in the files, at the file, the name, the start of it, you could do %files -f and then a file name, a local file name that's there in the build process. If your build process can write out those list of files, I know Systemd makes really heavy use of this in their package. That's another one, yeah. So Systemd does that. So during the build process, Systemd writes out that this component of Systemd has all of these files in these locations, and you can save that output into a text file just during the build process, not part of the package installation. And in the file section, just say files -f, this temporary file during the build, and it injects everything of that file contents into that. There's other macros. Another way, instead of listing every file exactly, we'll get into that there's a recursive way in there. I'll talk about that in the next slide, but there's another question. But there's several different ways to go about it. Yeah. No, one more.
Yeah, for the backporting, is it recommended for like tracking purposes? Because like in Git, you can like cherry pick commits, and it'll tell you like this commit was cherry picked from this upstream commit. Do you recommend in the changelog to do something similar? Like for backporting a CVE, maybe you'll put like the CVE number, but like, would you ever put like a commit to say like this was the upstream that I'm backporting? Or?
Yeah, it's a little bit of dealer's choice. There's definitely best practices around it. Like, for example, you're backporting a patch that fixes a specific CVE. You would want to put that CVE identifier. People look for CVE identifiers in changelogs. That's a great example of something you would do. I wouldn't just copy the upstream commit message in entirety and put that. That's probably, even if it's one line, that's probably too verbose. What I'll typically do if I'm pulling a patch from upstream is I will write add patch to change or fix this thing, backported from upstream or something along those lines. Or even better, rather than just say added patch for this thing, and then a link to like a Red Hat Bugzilla number with more information. So it's really good for putting URLs or like the bug number. It's really good for that. I've seen some packages where they will reference like an upstream pull request number and say like this is a backport of this upstream pull request that fixes this thing. Maybe they also have a CVE identifier, maybe not. But yeah, it's dealer's choice. It's whatever you want to put there. I would say best practice is the shorter the better. You want it to be very terse and just a quick something you can look at on the command line and understand.
Like
You would never put like the upstream like.
No. The patch content itself doesn't go in the changelog. That the patch itself is in that patch file, the one we referenced.
Oh yeah, you could just okay.
Yeah, there we go. You would have the patch in a file, like for the git. If you did git format patch, that gives you a patch file in like man list format. You save that as a patch file, and during prep, it applies that to the source code. And in the changelog, you just describe what you did in as high level term as possible. Like I'm backporting this patch for this thing.
So some real world advice here for what I usually do is if I'm backporting a fix or adding a patch or a feature or security bug or whatever, I will take the commit. I'll take the commit back as a patch, put it in as a patch line, and I'll put a comment line right above and say from, and either put a URL or the commit-ish or the reference, the pull request or whatever, because that detail is useful there when you're looking at the details. In the changelog, I'll just reference, as Carl said, the very shortest form possible to explain it, because the way you got to think about changelogs is that it's some dude who's possibly looking from an SSH terminal remotely on possibly his phone and needs to be able to read it. And from that perspective, you should make it the shortest, tersest, while still being understandable that you can possibly do, because that dude is not going to suffer through reading a whole bloody git log on his phone.
Yes, the level of verbosity is something to think about there. Another follow-up point of what he was saying, referencing like an upstream pull request or commit. In Fedora policy, Fedora and Red Hat in general, across the ecosystem of distros we have a policy of upstream first. And what that means is that we don't want to have changes that are just special to us. We work upstream first. I mentioned that a lot of the RHEL maintainers are also involved all the way through CentOS, Fedora, and the upstream projects. They're doing stuff in the upstream. They're getting those changes there. And everything else is like soft forks of management of what combination of these upstream commits we're going to do. It's really what it comes down to. But whenever you're doing a backported patch, you, in the Fedora packaging guidelines, in line with that upstream first policy, if you're adding a patch in Fedora, there's a should requirement. There's an RFC, I forget the number, but should versus must terminology, where you should, unless you have a really good reason, have a reference to where that backported patch came from. And if it's something you came up with yourself or got from somewhere random, you need to work to get it in the upstream project, because it's very annoying to have a huge long list of patches. Every patch you're maintaining in your package is making your soft fork a little bit more of a soft fork, a further divergence. And that can be very difficult to manage. The much more responsible way to handle it is to get that upstream, maybe even get it from upstream in the first place, so that way the next version of the software that comes out has that patch built in, and you just drop the patch file. That lets you stay at 0 or 1 or like single digit patches and drop them as time goes on. But then for some longer life distros like CentOS itself, you're going to have the opposite of that, where I do have to keep systemd on the same version or the kernel on the same version, and you end up with hundreds or even thousands of patches. But those are going upstream first. They're not just secret sauce Red Hat things or CentOS things in that case. They are things that are from the upstream project. There's not value in keeping those to CentOS or RHEL specifically, or even Fedora. Fedora has the same. Fedora can backport stuff sometimes. You might see it where new version of the software, it has the fix that we want, security or otherwise. But because of the way that change stuff, maybe a config file change or a library change, it's only appropriate to put that into Fedora Rawhide. Because Fedora releases also have a updates policy where you're not supposed to make big changes. It's just shorter life cycle, the 13 months versus like 5 or 10 years. So older Fedora releases might get a backported security fix that get dropped in the next Fedora release because they're included in the next version. All right, so that answer the question mostly? All right, we'll keep going. Where were we? The files section, I believe. Yeah. So, different adders. Adders is the last point, but yes. In files, each of those lines, you can precede it by a different attribute. The dir %dir, that'll just say, own this directory that I'm giving you, but not its contents, non-recursively. If you just listed a directory, by default it's going to include the directory and everything underneath that directory. Think like user include foobar. If you just put that in there, it's going to include that directory and every file underneath there, like the PC file and other stuff in there. But if you did the dir on user include foobar, you won't get any of those files underneath the directory, just the directory itself. And you may think, well, if there's files in there that I did in the build process, I want those pulled in the package somehow. Where that really comes in handy is where the package splitting thing, where you want some files in this subpackage and other files in this other package. dir gives you a lot of flexibility, so you can say the top level package owns all of the directories, and these subpackages own the files in those directories, and they may be different subpackages owning different files there. So it gives you a lot more granular control. Config lets you mark something as a configuration file, and it has a really weird, kind of dumb default, and I don't know the historical reason why, but if you just put config in front of the file, it marks it as a config file, but whenever you update the software, if the config file changed in the output of like the build system, it's going to replace all the local configuration when you install the package, which is almost never what you want unless the config file format has completely changed and the local config file is basically worthless. When it does that, it will save the old config file it's replacing as a .rpm save file. So it's not completely obliterated, but it's moved out of the way and might surprise people. Almost always, you'll want to use the next one, config with the parameter of no replace. That means, and if you've ever seen RPM new files on RPM-based systems you're managing, that's where that comes from. There's a new config file thing. Could be as simple as they changed a comment at the top, or they added new default directives, new sections, things like that. But that will create the config file with a .rpm new suffix, which is a signal to like the system maintainer that, hey, you've got a new config file and it's up to you to merge in the changes, but your existing one is probably still compatible with the software and things will keep working. But if I forget the exact, I think RPM conf, there's a tool that lets you find all of your RPM new files and RPM save files on your system and go through and merge them and manage them, or you just do it by hand. But yeah, config no replace is almost always what you're going to want to use. Nobody likes their config file getting clobbered on purpose. Adder is another thing you can prefix the line with. That lets you set the non-default permissions or ownership of things. All right. Some attributes will accept relative pass, which will copy the file into the build root itself. Most of them you're expecting to already be in the build root from your install section, and you're just listing where the file is. But license and doc, you can give it a relative path to like the license file in the tarball, and that macro will copy it into user share licenses or user share doc, and also mark it appropriately as a license file or a documentation file. For a long time, we only had the doc macro, and the difference between these is that you can skip documentation files. You can't skip license files because most licenses have a clause that you have to distribute the license with the software. So that's what the key difference is there. So creating spec files. You may want to create these from scratch. You could also copy a similar spec file and adjust as needed. That's real common. Some text editors have automatic templates. Like, for example, if you use Vim and you just type vim foobar.spec, it'll inject a basic skeleton of an RPM spec file. Just automatically, it understands the template. Other text editors have similar mechanisms. The tool you're going to use, actually, you don't use this one in the lab. We use another one. But there's a tool called RPM Dev New Spec from that RPM Dev tools package from the first lab. That'll create a spec file from a template also and just output it. Similar story with changelog entries. I mentioned that's the description between each version and release of the package as it changes over time. You could write them by hand. You could copy the previous changelog entry and then adjust it. You could use text editor plugins to inject it. But then there's a tool, you will use this one in the lab, called RPM Dev Bump Spec. What that's going to do is it'll add the changelog entry with whatever comment you pass that command, and it'll also at the same time adjust the release and maybe even the version if you need to, along with what changes you're passing into that command. And you'll see that I thought the lab was the next slide. It's going to transition right into it. So, but this is also about building RPMs. We're going to build them with the RPM build command. That expects the directory structure we made in the first lab, the RPM dev setup tree. We've got various build modes. BS is going to build the source RPM from spec file and sources. BB is going to build your binary RPM from spec file and sources. BA is going to build both. And then there's also another mode called rebuild that rebuilds an RPM from a source RPM. Quality checking RPMs. During the first lab, you installed the RPM lint command. That is a linter that will check spec files, source RPMs, and RPMs. It'll identify real common packaging errors. It's not mandatory to resolve all of those errors and warnings. It is good to try, but it does flag real common mistakes. But just understand that it's not always going to be possible. During the lab, some of the first examples don't have a man page with the program that you're going to package, and you'll get a warning in RPM lint that says, warning, no man page. Don't freak out, that's normal. It just happens sometimes. But that is a good indicator if you're packaging some real software on the internet and it tells you, hey, no man page. You might think, does the software have a man page and should I be including it? They do, let me add that. Or I checked and they don't. I'm going to file an issue and ask them to write a man page. Or write the man page myself and contribute it upstream. So, along with the RPM lint, you can also use the RPM command itself for querying packages. Most of the time when you're doing packaging work, you're not going to have these packages installed directly on your system. It's real common for package maintainers to be targeting a different operating system than what they're building on. And we'll talk about that in the last lab with a real cool tool called mock. But you can use, for an uninstalled package, you can use the RPM command, use the -- package flag, and that'll let you query information. A lot of people might have done like RPM-QI on an installed package before to show you the information about a package you have installed. You can do the exact same thing on a local package file that hasn't been installed by using the -- package flag. Some other flags that go along real good with that for inspection, -- info, list, your requires, provides. Those are going to be dumping out the relevant type of metadata that you're asking for on the command line there. So let's get into the next lab. More hands-on, so I'm not droning on as much. Y'all are gonna package a piece of software called Bello. That is just a dorky little name for a Hello World program written in Bash. Go ahead and click Start on your lab. And I know the people that came in late, if y'all want to join us, I'll show you the URL. But for everyone else, go ahead and get started on the Bello lab, and then stop whenever you hit the next button, or after you click Next. So people that are just coming in, not to call you out for being late to class, it's fine. But if you want to join in on the workshop, this URL here will take you to the hands-on lab if you have a laptop to work on it. It'll be up after the workshop, so if you just need to write it down and do it again later, you can. It'll walk you through all these labs. There's lecture that goes along with it, but there should be enough instructions there along the side that you can get caught up if you want to. And if you have if you're doing the lab and have questions, just raise your hand. Somebody with a mic don't need the mic, but somebody will come around and help you. I want to let y'all know that we're on a little bit more of a time crunch than I expected originally due to some great questions that I don't mind at all, just over my minimum budget for time. So I'm going to talk a little bit more about another packaging thing that we need for the next lab, and then open up the next lab so anyone that has already done with the bellow lab can start on the next lab. If you're still working on bellow, just kind of listen with one ear. This is the next slide's fairly simple, and then get to the next lab when you get to it on your time. If you run out of time doing the lab, you're not really going to run out of time. The SCaLE folks told me that there's nobody in this room after us, so we can actually go over and keep working. Or if you just have to get somewhere else and want to write down that URL and finish the lab another time, that's also an option. But keep working on bellow if you're still in that lab. But I'm going to tell you about something that you'll need for the next lab, which is installing build requirements. For bellow, there were none. It's just a bash script. Everything that's in the default environment is all you need to just get that file copied, and then you're done. RPM build, it needs all of the build requirements that are listed in the spec file to be installed on your build host. And you can do that either manually, just ahead of time, just install those by hand one by one. But if there's a lot of them, it's a lot easier to use a command called DNF build dep. And you will see that directly in the cello lab with an example of the exact usage, so I don't have to walk you through it. So when you finish the bellow lab, click next and go on to the cello lab, which is appropriately a Hello World program written in C. And actually, there's no more lecture before the third lab, which is also a Hello World program, but written in Python. So just move through those labs as you get time. Do not feel like I'm rushing you. If you have questions, just raise your hand and we'll come by and get you on track. Don't get too bogged down if something's not making sense. And then there'll be one little last piece of, I'll give that a little bit of time to not overload you. There's one little last piece of lecture about a tool called mock, and then a final lab on mock. We'll save that for like the last 10 minutes. When everyone's head down, working through the labs, going smoothly. All right. Here, I'll give you a couple more minutes just working freehand, and then I'm going to give you a quick little slide about what the mock tool is, and then tell you about the last lab, and then you can just finish when you finish. One more slide of lecture to tell you about a really cool thing. So during all these labs, y'all have been using the RPM build command. Now I want you to throw all that away because you're not going to use that normally. I'm halfway kidding, but there are drawbacks to using RPM build directly. I mentioned that with the DNF build dev thing, your build requirements have to be installed on your host machine, on your build host. It's also really easy that if you have a build requirement that is already installed, to forget to list it as a build requirement. Like if your software needs GCC to build the package, and you have GCC installed for some other reason, and you build your package and you don't list build requires GCC, somebody else that tries to build it might fail to build because you didn't list it as a build requires. So it's entirely too easy to get in that situation whenever using RPM build directly. You can also only build RPMs targeting the same operating system and operating system version as your build host. So your build host there in that lab, it is a CentOS Stream 9 system. And so you really can only build RPMs that officially target that. You might be able to make an RPM that accidentally installs on another version or on another distro like Fedora, but it's not guaranteed, and you'll probably run into library stuff eventually that for not targeting correctly. But there is a solution for that, and it's called mock. And that lets you build RPMs in isolated cheroots. It still uses RPM build internally in its guts, but it gives you the benefit that your build requirements are not installed on your host. They're installed inside that cheroot and then discarded when you're done with the build. That'll help you identify any missing build requirements, because in that cheroot, it is a very stripped down, minimal, just the bare minimum structure for getting a build done. And it'll tell you, like, I also need these development libraries or this compiler installed to complete the build. Even more importantly than that, that's a great benefit on its own, but it also lets you build RPMs that target different operating systems or operating system versions as the build host. Limited, right? Like, there's some limited support for doing different architectures, but you have to have cross-compile support, I think. Okay, so that's gotten better then. So there are also ways you can use mock to do different architectures, but that's, yeah, you probably won't be doing that. Yeah. Those cheroots that it makes are also automatically created and removed and managed, so you don't have to really think about it. It's just, you might end up with a fairly large varlib mock directory over time that sometimes you might want to purge manually. Mock is really widely used in our ecosystem. It's the Koji build system that Fedora uses mock inside of it. The Copper build system in Fedora also uses mock. So they have a standard backend essentially. The Fedora Fed package tooling, if you get into being a Fedora packager, it also integrates really well with mock. And that's what you're going to learn about in the next lab. You're going to build the Pello package again, but you're going to use mock to do it. And instead of building it for EL9, the same as your build host, you're actually build it to target EL8 instead, and then inspect the results.
Does the EL stand for Enterprise Linux?
Enterprise Linux, and the answer is yes. CentOS Stream is the reference implementation of Enterprise Linux. We're close to the end of our official time. Keep working on the lab if you need to. I'll still be here I'll basically be here till they kick us out. But one other thing I want to bring up is if this was interesting to you and you enjoyed these labs, then I would encourage you to consider becoming a Fedora /EPEL packager. This URL here, bit.ly/Fedora packager, that'll take you to a page in the Fedora documentation about becoming a packager. Coincidentally, that is great background for getting involved contributing to CentOS as well, because it's a lot of overlap in these ecosystems, these communities, and the tooling's mostly the same across, and it's all relevant and connected. So if this, like me, if it scratches an itch in your brain where this was interesting and exciting to you, check this out, and I hope to see you around Fedora and EPEL and CentOS spaces. That's basically the end of the stuff, but keep working on the labs. I don't know if Sean wants to say last words for the overall thing.
No, not last words. I just want to say, like, if you have, you take this back and you then have more questions and you want to find Carl, there is a CentOS booth. Exhibit hall opens tomorrow afternoon, I think, or whatever. So there's a CentOS booth. We'll be there. Yeah. There's also a Fedora booth that you can go visit, and people there know stuff too. So there's both a Fedora and a CentOS booth, and a Red Hat booth apparently. So yeah.
But yes, you don't have to get out of here. You don't have to go home, but you have to get the hell out of here. No, I'm just kidding. I'm gonna be here till they kick us out. If you want to keep doing the labs, feel free. We ran a little over on some of the lecture. My fault. So we will be available and or write down those URLs. It was bit.ly hello RPM and Fedora Packager were the two URLs to get to the hands-on lab and to the become a packager documentation. If you want those again, yeah, I'll be here. If you have more questions on the lab, just raise your hand.